Professor PROF.C.R.RAO. Good morning.
So, how are you?
Oh,
Okay. Unmute yourself. You're muted. Where are you these days? Delhi or?
Delhi. We are one of the largest polling places.
And also, I'm still in Hyderabad. Settled in Hyderabad.
Yeah. You still go to IMFA?
I taught a course, online course. I teach in the doctoral program. I stopped teaching in the MBA. I have some problem with my legs, so I can't stand for too long. I have to sit and so on. The MBA course, you have to keep moving around and so on. Doctoral course, small number and so no problem. I just finished a course, linear algebra. How about you? What are you doing in the course?
Nothing much. In fact, I don't teach anywhere. That was one of the things which I did after my return, not to teach anywhere.
No more teaching.
That nobody is interested in how to teach. Only thing they want is certificate.
Yeah. But some in doctoral programs you might have, because I don't know, they may have enough faculty. I don't What is your wife doing by herself? She's also retired?
And so she basically worked in this artificial neural network area. She was involved with some startups. She also has some urgent appointment with IIT Delhi guides for PhD students. Busy.
Very good. So still active research-wise.
Yeah, quite. Malik, good morning.
Good morning.
Good morning, sir. Good morning.
Good morning, everyone.
Professor Mittal, good morning. We'll have very happy
Good
to
morning.
see
Very good morning.
Yeah.
We are meeting each other on the Facebook frequently, you know.
Yes, constantly we are in touch.
Correct.
Professor Rajshekar Reddy, many happy returns of the day.
Yeah, happy birthday, Rajshekar Reddy.
Thank you, thank you. Thank you, sir. Thank you all.
Happy birthday. You are ready.
Yeah, thank you, thank you.
Happy birthday to you, sir.
Where is the cake?
Yeah, we should.
On happy birthday, we are starting this conference.
Yes, sir.
Very, very joyful.
Happy birthday to you. Dr. Rajశేఖర్ Reddy.
Thank you. Thank you, Anand.
Happy birthday, sir.
Thank you, sir. Thank you.
Is there మీ పేరు ఏదే వెంకటేశ్వరన్ అని వస్తుంది?
అన్నా చెప్పనా Yes, we'll start the program. Om Namo Venkateshaya. A very good morning to all of you. On behalf of the webinar program committee and also on my personal behalf, I am delighted to welcome you all to this international webinar. I take this opportunity to invite the distinguished dignitaries for the inaugural program. Dr. K. Chandra Reddy, Chairman, AP State Council of Higher Education, Professor D.N. Reddy Garu, Director of PROF.C.R.RAO Institute, Professor PROF.C.R.RAO Garu, former Dean, Indian School of Business Management, Professor Allam Apparao Garu, former Director PROF.C.R.RAO Institute, and Professor K. Srinivasarao, former retired Vice President of War Society of India, and another friends, Professor Aruvaragnan and other B.R. Vittal, Kalpalata Reddy, Professor Anandaracharya, the founder, Professor of War. Invite Invitees and invited speakers from various academic institutions, IIT, IIM, ISI, NIT, and other universities from India and abroad, the Executive Council members of War Society of India and various chapters of War Society of India, operational research scientists, faculty members, research scholars, and students of engineering, maths, statistics, management, and computer sciences departments. My warm welcome to you all. At the outset, I am extremely happy that some senior academicians responded positively to our request to present an invited talk in honor of Prof.C.R.RAO Centenary celebrations. On this occasion, it is very appropriate to recollect that two legendary names. One is Professor P.C. Mahalanobis, founder of Indian Statistical Institute, who established Operational Research Society of India in the year 1957, and he was the first president of ORSI. For all his significant contributions in statistics and operation research, Government of India in 2007 declared as National Statistics Day on June 29 on the eve of his birthday occasion. Another legend is Padma VIBHUSHAN Dr. C.R.RAO, former director of Indian Statistical Institute and India Science Awardee in 2009. At the advice of Professor C.R.RAO, SV University has initiated a new PG course of War and SQC at SVU PG Center, Kurnool. Now it is called Rayalaseema University. Prior that, Delhi University offering a 2-year PG course in War. As you are all aware that the War Society of India is affiliated to the Federation of Operational Research Societies and the Asia Pacific Operational Research Societies AWARDEE. Several chapters of this society are active across the country. The members of the War Society of India are spread all over the world. First annual convention of the society was held in 1968 at headquarters Calcutta. Since then, the convention has become a regular annual event providing practitioners and researchers in war a platform for disseminating their works and experiences at the peer level. The ORSA publishes a quarterly journal after published by Springer, which is recognized as one of the leading journals of war in the world. The AWARDEE plays a major role in the publication of Asia Pacific Journal of Operation Research. The IPORS is recognized by the United Nations as a specialist world organization. Coming to our War Society of India Tirupati chapter, War Tirupati chapter was established in the year 1999, which was inaugurated by Professor Shadagopan, Director of IIT Bangalore, and Dr. I.V. Subbarao, the Executive Officer VDD, was the chief guest. The society undertook the stewardship of Professor Shadagopan, evolved an excellent scientific procedure in helping the Tirumala Tirupati Temple administration in introducing a clean theory application concept Sudarshan token system, which proved to be an excellent application in reducing the waiting time of the pilgrims for the Lord's Darshan. Till today, there is a lot of innovations in the Darshan timing and everything. It is only on slot Darshans. The society also undertook many scientific studies in different areas of temple administration, besides helping many postgraduate and professional students in carrying out their dissertation thesis work. The society regularly conducts several academic programs in organizing seminars, workshops, symposia in association with the Indian Society for Probability and Statistics and the Department of Statistics, Venkateswara University. The ORSA Tirupati chapter conducted 32nd ORSA in 1999, 41st in 2008, and 47th in 2014. International conferences and a special session on war in temple management is arranged with the help of Tirumala Tirupati Devasthan. A project, research project entitled Design and Development of Fuel Analyzer for Stochastic Flow Control Systems and its applications to Tirumala Tirupati Devasthanam Fuel Company, sponsored by DST, and this is now and submitted to the Tirumala Tirupati Devasthanam. And our chapter also organized various surveys and feedback on footpath pilgrims, AP tourism, feedback about the Sudarshan token system, time analysis and in and out of the Shivari temple, 300 rupees ticket, online, etc. We have organized. And during the last 60 years, war has evolved as multidisciplinary function involving economics, mathematics, statistics, industrial engineering, and others. I am sure this webinar would make an important beginning in the transition efficient of effective use of war methodology in building a prosperous India. The webinar theme advances on war for optimal humanosphere is in tune with the views former Honorable President of India, late Dr. APJ Abdul Kalam, on how India should transform itself as a developed country. It is an undeniable fact that our country has arrived on the global scene in order to achieve this transformation. Several new initiatives are underway. I am of the opinion the principles and methodology of war can play a crucial catalytic role to enable the decision makers to evaluate the alternatives and implement the best course of action. I am confident that the next 3 days the invited talks in this webinar would provide an opportunity to enrich our academic collaboration, explore new areas of applications on war in the context of India, and network among fellow professionals. Thank you. So now I request the inaugural message, since our chairman is about to, M. Centenary is about to die. So now, meanwhile, I request Professor M.R.RAO Garu to give the inaugural message on this occasion.
First of all, I want to thank Sir Rajshekar Reddy Garu. Are you able to hear me all right?
Sir?
You're able to hear me all right?
Yes, sir.
Thank you very much, sir, for inviting me for this session and also give the inaugural address. I have known Dr. C.R.RAO for a long time, but more recently, meaning in about last 15, 16 years, since I moved to the Indian School of Business, I came to know of him a lot more. He has, of course, made stellar contributions in statistics and has started the C.R.RAO Institute, on which I am on the board of the governing council. And I think the institute is coming along well. And recently we had his centenary birthday celebrations, and he was online, and it was nice to see him. So I wish the conference all the success. I wish also Dr. C.R.RAO many more happy and healthy years ahead. It's a pleasure to be here, and I once again want to thank Dr. Rajshekar for inviting me, but not only for the inaugural session, but also to give a general talk on business analytics. I would change the title slightly to operational research and business analytics. I will do that, I think when the first session starts. Thank you very much.
Yes, sir. Thank you. Thank you, sir. Thank you for your valuable message. Now I request our former president, Dr. Ashok Kumar Mittal, and he was the former professor of IIT Kanpur. So now I request Professor Ashok Kumar Mittal.
Thank you, Professor Nukeshwar, Chairman and delegates. I feel privileged to be part of this conference to celebrate birth centenary of PADMA Professor C.R.RAO, a living legend. While I never had a chance to work with him, I have good fortune to know him and his family as his family friend of my life. Myself, my wife, and daughter were fortunate to spend a few hours and share lunch with him and his daughter at their home in Buffalo about this time last year. While his contribution in statistics are well known and need no mention, very few may know that he is a passionate photographer. During our visit, he shared some of his photographs. We will cherish those moments forever. We will remain indebted to him forever for establishing an Institute of Excellence in the University of Hyderabad. I wish him many more years of fruitful life. I also wish the conference organizers a successful conference. Thank you.
So now I request Vijan Sarkar, the Secretary of the War Society of India. Now I request Dr. Vijan Sarkar, the Honorary Secretary of the War Society of India, to speak.
It is a great pleasure for me to be here on this great occasion of great son of soil of India, great statistician in the color of the world academic map, PROF.C.R.RAO. I am thankful to Professor Reddy, Rajshekhar Reddy, for giving me this opportunity to say a few words. Though I have not met him in my lifetime with him, but I heard of his great achievement, outstanding achievement in his career. And I also wish the success of this conference for the 3 days, consecutive 3 days. Thank you very much.
Vijan Sarkar. Now I request Professor Anandarachari, the founder professor of War and Ethnology, Kurnool, is it. మైక్ ఆన్ చేసుకోవాలి శ్రీనివాస్ ఆనందరాచారి అన్మ్యూట్లో ఉంది అది.
Please unmute your mic, sir.
చాలా రైట్.
Again, I also unmute, sir.
Yes, sir. Anand.
Am I be audible?
Yeah. You are now audible.
Thank you. Good morning to all. Thank you, Professor Rajshekhar Reddy, Honorary President of ISPS, for inviting me to take part in the inaugural session of this webinar to delineate some of my remarks on the webinar. I am happy to participate in the webinar on the advances in artificial research for optimal humanosphere and organized trading operating society, India Tirupati chapter, in association with the Department of Statistics, Venkateshwara University, and the Sri Venkateshwara Engineering College, Tirupati, Indian Society of Probability and Statistics for 3 days from today till the Sunday, 22nd. In connection with the birth centenary of VIBHUSHAN, legendary statistician Professor Kalyapuri for the teaching of I have met twice or thrice during my student stage in 1976 in the conference, and again in 1986 when Professor M.P. Sastry, founder of the professor, was retiring. I had an opportunity to meet him and have his deliberations. So that was the second occasion. Except otherwise, I don't have a complete rapport with him. However, I would like to have a brief about the PROF.C.R.RAO. PROF.C.R.RAO was a disciple of Professor Muhammad, architect and founder of the Indian Statistical Institute. He was a research scholar under great mathematician and a father of statistics known as AWARDEE of United Kingdoms, a great scientist of the 20th century. Professor Rao was the youngest scholar also in 25 years. He has published research in the area of statistical inference regarding estimation of statistical parameters, which judges the precision of the estimates of the best result. These were cited in the book of statistics published in the last century also. The well-known parameter of inequality, the Rao blackization, for some of the famous results shared with eminent statisticians like Lamar of Sweden and Blackwell of America. Professor Rao has 39 honorary doctorate degrees from the various universities in and around the world, and he had 51 PhDs awarded under his guidance. Nearly 470 research publications were appeared in various reputed journals, and authored 15 very good books and edited 39 volumes of handbooks. And Professor Rao's 100th birthday was celebrated recently on 10th of September 20th of this year, and is leaving the lesson. He was a former director of ISI, retired voluntarily, attaining the age of 60 years, and presently holding honorary professorship at Pennsylvania University and State University of Buffalo at United States of America. As an opportunity to be a part of his 100th birthday celebration, sharing virtual platform through webinar, advances in statistics and data science was substantial human development organized by the ISPS and the Department of Statistics alumni during service to 10th of September 2020 in this connection. The present webinar is a consequence of the Professor Rao's centenary birthday celebrations organized by the Operations Society of India chapter Tirupati in association with Venkateswara Engineering College and ISS. Operations Society of India was established, as was pointed out by the Honorable President, in 1957 by the founder President Professor P.C. Mahalakish, and this is affiliated to International Federation of Operations Research Society in India and Asia Pacific Operations Research Society. The activities are well known: annual conventions of publications in the leading research journal, quarterly journal in this area of such, and Asia Pacific Journal Operations Research. ASI Tirupati chapter was established in 1999 and inaugurated by Professor Sada Gopalan, then Director of IP, Bangalore. The Sudarshan token system using fluid model application under the guidance of Sada Gopalan was evolved at Darshan at Lord Venkateswara Tirumala Tirupati Devasthanam as the best operation till date. TTD is regulating this system, reducing the waiting time in the pilgrimage for Darshan to Lord Venkateswara, doing away the hardship to the pilgrims. Coming to the Department of Operations Research, Kurnool, it was during the fifth plan period, 1975 period, University Grants Commission has conceived an idea for university extension centers extending to district headquarters to increase the number of seats at postgraduate level to take care of the increased output of degree holders at this time point. So also, UGC was thinking to decentralize the postgraduate education in order to establish these centers in district headquarters of the local area of respective universities. During this time, Venkateswara University authorities had contemplated 3 extension centers in the districts of Indore, Kappa and Kurnool, each with 2 departments in the local areas of Sri Venkateswara University, located in Chittoor district in Andhra Pradesh. Further, UGC was insisting to start PG courses which were catchy and career-oriented and are suitable to the local needs of the area concerned. So at the time point, then Vice Chancellor K. Sachidanand Murthy assigned this task to then UGC coordinator, the founder of the Statistics Department, Professor M.P. Sastry, to accomplish this, with an advice to start courses in the areas of statistics and economics, with novel courses as per the idea and the process of the University Grants Commission. It is at that point of time, Professor Sastry consulted Professor C.R.RAO, having intimacy with him, he decided 2 areas of statistics, that is industrial statistics and optimization models. Combination course is important at the statistics. As a result of that, the 2-year PG course in operations research and statistical quality control will be postgraduate department of OR and Business, initiated at Venkateshwara University Extension Center, Kurnool, during 1977 November. I am an alumni of SV University Department of Statistics during 1974-76. Fortune that I am a student along with Professor Aseka Reddy in the batch of 1970, 76 and 74 and 76. And an opportunity to pursue the Master of Philosophy research course in the first batch during 1976-76. Along with him, being initiated by Venkateshwara University, similar line of of course, it's my fortune to be in the first batch of research course of this university. To get selected as assistant professor in the department of OR and SPC at Kurnool, and served as the faculty head of the department, chairman boards of studies, nearly 38 years and retired in the month of April 2014. In fact, it was a unique department and a course at postgraduate level in the southern part of the Indian universities, except the one in Coimbatore University and other Delhi University, apart from Indian Statistical Institute. So this course had an essential component of project work for 4 months, and the students were pursuing this in various industries from the major cities in southern part of India, Hyderabad, Bangalore, Chennai, and in and around places of Kurnool, Anantapur, Indapur, Adon, Telugu. So the students were well involved in the project work and had practical experience in some of the industries like Electronic Corporation of India, HMT, VHUL, EDPL in Hyderabad, University of Chennai, Indian Chemical Industries of Bangalore, paper mills, Rayalaseema, APSRTC, UAPB, Kurnool, spinning mills at Indapur, oil mills at Adon, etc. The students with this good experience in real arena of various industries, in the industrial and IT sector, as well with exposure of beautiful learning knowledge conveyed in the curriculum course. The department of the course, with its academic curriculum and practical exposure through project work, become an advantage to the students in career programs. So this has created an idea to start courses with this specialization in industrial statistics and quality control in similar lines of other universities, namely Centenary University main campus, Tirupati, and Acharya Nagarjuna University, Guntur, and state of Andhra Pradesh. So with this, and I come to the last part of this webinar. So the theme of this webinar is content and operations research, ideal of this nature, the conduct recent trends, ideologies or methods and logics to benefit the statistical, mathematical, specific, and individuals and corporates, sectors, the speakers from the national, international will certainly create, impact, inspire proceedings and maximize the theme and goal of this webinar. Delegates and research scholars will have graceful sessions requiring benefit input to the areas of interest and will be benefited by their future progress. With this brief reports, I will be made to thank the organizers of the webinar giving me an opportunity to participate in the inaugural session of this webinar. I particularly thank you because Asik Reddy, the honorary president of the SPF, who is steering this entire process of the webinar as we are closing the best. Thank you very much.
Thank you, Anand. Now I request Professor M. Chandra Reddy Garu, the chairman of the State Council of Higher Education. Sir, M. Chandra Reddy Garu. Now I request Professor P.R. Vittal to say a few words for 2 minutes, sir. Okay. Rajesh, line లో ఉన్నాం. Professor M. Centenary is going to join another 5 minutes. So meanwhile, I request Professor VIBHUSHAN to speak on the theme of this webinar. Now I request VIBHUSHAN.
Good morning, everybody. At the onset, let me thank the organizers, especially my good friend Professor VIBHUSHAN, for giving me an opportunity to associate with this webinar. I am very happy to associate with that. In particular, this is in conjunction with the PROF.C.R.RAO Centenary celebration, and ORSA chapter of Tirupati is organizing this. And Professor VIBHUSHAN's birthday. So, a very, very happy birthday to Professor VIBHUSHAN. Coming to this webinar, when the organizers thought of organizing this webinar, Professor VIBHUSHAN contacted me to suggest a good theme which should be somewhat different from the earlier themes that was taken up. Then I thought of, and it is the HUMANOSPHERE, that is the human development is the most important consideration for any discipline for the development of it, and the tools that was taken. In that perspective, I made a suggestion, it should be war and HUMANOSPHERE, it should come, and finally it came out as advances in operation research for optimal HUMANOSPHERE. Thank you, sir, for choosing the theme which I was suggested to you. And HUMANOSPHERE is, when we think of, many people are asking what is this HUMANOSPHERE and how it is related to war. HUMANOSPHERE is defined as the part of the earth inhabited by or influenced by humans. This uses a framework that is made up of 3 spheres: the geological, biological and societal. Each one of these operates according to its own dynamic logic. Combined, these encompasses a holistic, life-centric and long-term general equity approach that recognizes the roles of each sphere in supporting life in the broadest sense. The geosphere is the oldest and largest of the 3 and provides the geophysical basis for the other 2 spheres and life in general. Incoming solar radiation, the primary source for almost all life that has developed and evolved on the Earth, acts as and provides the driving force for the global circumstances of air and water. The second, the biosphere, under solar radiation and global air and water circulation, has over millions of years converted organic materials into an amazing area of diverse self-replicating organisms. These have come in exhibit almost all of the Earth's major territorial life zones. The third, human society, has over the past several years arisen from the biosphere and is its most recent development. It resides within what we classify as a human-oriented societal sphere. Over the past couple of centuries, societal metabolic activities have came to exceed the capacity of what the biosphere can support. Combined, these 3 make up the HUMANOSPHERE. For this, we believe a sustainable HUMANOSPHERE can only be achievable when the interlinked potentiality of all these 3 spheres are considered holistically and measured through their relations. Potentialities are defined as those factors that represent the potential of the geosphere, biosphere and human society and constitute the basis for any form of sustainability. Various professional societies have made various efforts to assess sustainability and there now exists a prevailing present future risk in global warming and biodiversity losses. Increasingly, research on global environmental changes has been interpreted by calls of profound societal change and the future forms of governance that can be respond to this uncertainty, a key issue at the heart of the debates of sustainability. Within the heightened context, there has been a boom in the development of sustainability indicators that have come to be increasingly recognized as useful tools for informing policy decisions and communicating changes take place at a global level. Human Development Index was strategically developed as an indicator that could compete with the replacement of GDP. It aimed to express the concept of human development based on American's capability approach. To date, the United Nations Development Program has focused on health, education and income as basic functions that should be included in approaches towards human development and adopted average life expectancy, literacy rate towards human development and adopted these indicators. As per GDP as a component, the world based on Human Development Index countries rating does not depart radically from the based on GDP rankings, although HDI includes factors other than production levels. As its name implies, HDI focuses primarily on human society and that sense it is limited by its strong bias towards human, in that it does not directly consider environmental constraints. As such, there is a need to rethink the capability approach and reassessment how we can measure present global potential within the framework of sustainability and go beyond the primary focus on the needs of human society. Operation research encompasses the development and use of a wide range of problem-solving techniques and methods applied in the pursuit of improved decision-making and efficiency, such as simulation, mathematical optimization, queuing theory, inventory models, stochastic processes, Markov decision process, economic growth, data analytics, neural networks, expert systems, decision analysis, and other analytical hierarchy processes. These all will be very useful to develop the sustainable human development index. Operation research focuses with a new problem must determine which of these techniques are most appropriate given the nature of the system, the goal for improvement, and constraints in time and computing power, or develop a new technique specific to the problem at hand. Several war scientists are working on this part of development of the human and the economic growth. Development must surely be one of the most frequently used terms in public discourses. The ORSI and its members are working thoroughly to improve human development and national growth. I am sure the deliberations made in this webinar will definitely provide new knowledge for optimal HUMANOSPHERE. I thank the organizers for the given opportunity and I thank every one of you for having your time to participate in this inaugural function and this webinar. Thank you all.
Thank you, Professor Srinivasa Rao. Now, before going to start the keynote address by Professor M.R. Rao, now I request Professor M. Chandra Reddy to give your he is also as a war scientist. So now I request Professor M. Chandra Reddy to give his valuable speech. Sir M. Chandra Reddy.
Thank you, Dr. Venkateshwaran, for giving me this wonderful opportunity to be amidst you, the scientists, discussing the operational research for optimal HUMANOSPHERE. I take this opportunity to congratulate the organizers, particularly Professor Rashid University, for bringing on the distinguished academicians and researchers on one platform and discussing a very pertinent and useful topic today. I know this society is doing a a great job, addressing various problems being encountered by the society on the whole. And I'm sure the deliberations today will go a long way in changing the complexion of the society as such, and then improving the living standards. So I don't want to take much of your time. I just don't want to stand between the organizers and the keynote speaker today. I just wish this program the very best, all the very best, and looking forward to the outcomes of these deliberations, so that if some of the points that we can take it up at the state level, at the state level for implementation, probably for the policy interventions. We'll be looking forward to it, and wish you all a very happy time and a learning experience. Thank you very much.
Thank you, sir, for your good words. But now we are after preparing the report. Definitely, we will submit to take couple of identifications, sir. So thank you, sir. Thanks for what you said. Now I request Professor M.R.RAO garu to speak his keynote address. Before going to speak, I am happy to introduce Professor M.R.RAO. Professor M.R.RAO is known as I'm happy, sorry. Professor M.R.RAO is known as Professor M. Ramohan Rao. He did his Bachelor Engineering at Madras University, Mechanical at Madras University. Later he did Master Engineering, Industrial Engineering, Cornell University. MS Industrial Administration, Carnegie Mellon University. PhD from Carnegie Mellon University. And Professor M.R.RAO was the former Dean at the Indian School of Business, Hyderabad from 2004 to 2009. During his tenure as Dean, ISB was ranked globally in the top 20 by Financial Times rankings, and former Director of Dean and Professor of Indian Institute of Management, Bangalore. During his tenure as Director, IIMB was ranked number 1 in India by the Business Today. Cosmod, it is a survey of Cosmodi. Former Provost, Watson School of Business, Hyderabad. Former tenured Professor of Operations Research at the Stern School of Business, New York University. Top ranked business school in the USA, and was the President, Association of Indian Management Schools, President of Operational Research Society of India, Chairman, All India Board Management Studies, first Dean of Indian Schools, Business School, to be appointed as a member of the Graduate Management Admission Council, Chairperson of the Derivatives Market Review Committee appointed by SCBI, nominated by the Ministry of Human Resources as a member of the Executive Committee of the National Assessment and Accreditation Council, member of the IRDA Advisory Committee, member of the PAS Audit Advisory Committee, member of Advisory Board of Directors and Governing Council of several reputed organizers. He has published over 90 articles in various professional journals. He has received numerous awards, including the prestigious Fulkerson Prize in 2000, awarded by the Mathematical Programming Society and the American Mathematical Society, the Chief Executive of the Year 2000 to 2001, award by the Institute of Materials Management, the Ravi J. Mehta National Fellowship Award in 2003 from the Association of Indian Management Schools, Lifetime Achievement Award from the Operational Research Society of India in 2005, Professor M.C. Puri Memorial Award in 2008 from the War Society of India, the Lifetime Achievement Award in 2009 from the Association of Indian Management Scholars International, in the 2013 Aima Keval Lohiri Award for Academic Leadership in Management Education, Dr. P.N. Singh Memorial Award for Outstanding Academic Leadership in 2017 from the Higher Education Forum. So I am very happy, sir, to introduce you. Now I request you to give your keynote address on this occasion. Yeah, thank you.
Please unmute your mic, sir.
Sir, please unmute your mic, sir.
Yeah, I did. Sorry. Let me repeat. Thank you very much, sir, Secretary Garu. Is it possible to have my presentation screen?
Yes, sir. Sure, sir. Yeah.
I will present it.
Yeah, okay. So I first of all want to thank Professor Secretary Garu and the organizers for inviting me to give the address in the inaugural session. And I was also taken aback when I saw the title Advances in Operational Research for Optimal HUMANOSPHERE. I didn't know what exactly it meant. Professor Srinivasarao Garu had explained what it means, but I also looked up, nowadays Google search can give you some information. But I was not sure I would be able to talk about all this development for HUMANOSPHERE, so I told Dr. Asher Garu I will talk about business analytics, which is sort of gaining a lot of importance and a lot of buzz now these days. So I changed the title slightly differently to Operational Research and Business Analytics. The first part may be well known to many people, but can you give me control so I can change, or you will have to, I will have to ask you to change? You will change? Okay. Can you go to the next slide? So my presentation is first, of course, not needed. All of you know what operational research. I'll be very brief about it. The evolution of business analytics we look at from operational research to business intelligence, then business analytics and so on. But I'll spend some more time on business analytics. Basically, a lot of multivariate statistics where I think it's appropriate that C.R.RAO's contribution to statistics should be recognized, but in terms of business analytics, they talk about multivariate statistics a lot. Some mathematical programming, computer science and so on. And different types of analytics I will talk about: descriptive analytics, prescriptive analytics, predictive analytics, and so on. So I'll close with some concluding remarks. Can I have the next slide, please? So operational research, of course, Americans call it operations research. Started during the World War. Unfortunately, of course, nowadays there's a lot of mathematical approaches, techniques, and seems very little to do with operations or research. Sometimes people get confused, wow, what is this title and so on. But nevertheless, it's a very useful tool for many problems, both in the business world as well as in other organizations as well. So a lot of application of analytical methods for better decision making is one definition. Analytical methods include mathematical modeling, statistical analysis, optimization, simulation, and so on. Excuse me. So another term for this is management science, the business use of operations research. Sorry, can you go back? Can you go back to the slide, please? Okay. The management science is basically interdisciplinary approach that has gained more popularity because useful in the business context. Both are used to refer to decision making in organizations. Go to the next one, please. So you look at the evolution, started with operational research, and its use in business organizations has led to the development of decision support systems. Some of you who are old-timers in operational research would know that in management science especially, not so much in operational research but in management science, decision support systems became quite popular and used, of course, for a short duration. Then came business intelligence. What is this business intelligence? It refers to collecting data to get information through asking questions, reporting, and online analytical processes. Business analytics uses also many of the statistical, quantitative techniques and so on, predictive models and so on. Next slide, please. So it tries to answer questions as what happened when, and a lot of data, because data collection, data mining are all part of business intelligence. Business analytics, business intelligence, it should be, tries to answer questions such as why did it happen, what if things change. So business intelligence and business analytics have a lot in common, but there are some differences. Some features are different, which I will indicate. Both involve data mining, neural networks, multivariate statistics, optimization, and so on. Descriptive, prescriptive, and predictive analytics. Next slide, please. So, the big difference is when you talk about the interfaces of business analytics is the use of large data and computer science. So, business analytics is also analytical data-based decision making, it's called. Because, when we were talking about quantitative methods and so on, a popular saying among the people in faculty in human resource development or organizational behavior, they will say analysis paralysis, meaning you do a lot of analysis at the end, you don't know what to do, and so on, you're in paralysis. Hopefully with business analytics, there's no more analysis paralysis. Because I used to always argue with them, it's not analysis paralysis that we are suffering from. We are suffering from perceptual paralysis, meaning that we keep arguing about my perception as opposed to your perception without really looking at the data and without doing anything. So with the business analytics, hopefully, I think the phrase analysis paralysis will be not popular anymore. Because data is very important, and business analytics, data management is also an important aspect. But if you are optimizing, you can approach business analytics from 3 points of view, from operations research, optimization, or multivariate statistics, or from computer science. So depending upon which area you are in, you may be placing more emphasis on one. But business analytics includes all 3. Forget about that. People only think about that particular domain, which may be optimization, or which may be multivariate statistics, or which may be the computer science. So data management becomes very important. Because these days with fake data, fake news promoted by none other than Donald Trump, President of the US, reliability of data becomes very important. People are just putting out data to fool you, to make it look like your sales are very high, or people are very positive about your product, and so on. There is a lot of fake data these days. So interpretation of data also becomes important. The classic example that I've heard of is company executive sent his salesman to go to a village and they want to promote the use of shoes and so on. So first one person went there and said they saw, they were all walking barefoot and so on. So he came back and said there's no market there because they are not, nobody is walking with any slippers or anything. So then another salesman went there and so on. He also saw they were not using any shoes. No, he said there's a great potential because they're not using any shoes. We can promote it. So it's a question of how you interpret the data. You get same data is interpreted in 2 different ways by 2 different salesmen. One salesman thought that there was no market for that because people were not using any shoes and so on. Whereas the second salesman thought there was a great market potential because nobody was actually wearing shoes. So interpretation of data becomes very important. Of course, nowadays the issue of privacy and confidentiality are important. So business analytics has to be concerned about that as well. Next slide, please. Next slide. So business analytics, as with business intelligence and so on, involves knowledge discovery. We have large amounts of data. Now, of course, one big difference with reference to business intelligence and business analytics is the large amounts of data that's now available. So data cleaning has to be done and integrate the data. So there's some data transformation, all that has to be done before you go into data mining. Because with these days of all kinds of fake data, you have to be very careful. Data mining is trying to see relationships, trying to find out what the data is actually saying and come up with some presentation to what you have found from the data. The main constituents of business analytics, according to me, is multivariate statistics, where CFO, C.R.RAO had made lots of contributions. Unfortunately, of course, business analytics only talks about multivariate statistics, not in particular about contributions made by individuals. Of course, in all their fields, they don't talk much about contributions made by different people. And then, of course, it also involves mathematical programming, lots of optimization and so on. And the big difference from business intelligence and so on is computer science, artificial intelligence are all become part of business analytics. So if you really talk about a program in business analytics, towards the end of my talk, I'll mention about a program business analytics that ISB offers and a certificate. You have to talk about all these three things, multivariate statistics, mathematical programming, computer science, and it's a business analytics means that you have to be concerned about business, so you have to worry about what our business is all about, what are the functional areas, how we can use them. So all these are important. Next slide, please. So multivariate statistics, I don't have to talk to you about all these various techniques, multiple regression, logistics regression, correlation analysis. Cluster analysis is very popular from the point of view of marketing and so on, finding out clusters, the types of customers who are likely to buy your product and so on. Discriminant analysis, I think, where Professor C.R.RAO has also made a lot of contributions. Basically, classifying your customers. If you are having a credit card company, you would like to classify your customers as good customers, or those who will pay, or those who may default on loans and so on. So discriminant analysis, factor analysis, conjoint analysis is more recent, giving weights to various attributes based on choices expressed by consumers. Just getting the data of choice between two different products and so on, you identify various attributes for the products and giving weights and so on, and it's basically an analysis to identify which attributes are more important. So multivariate statistics plays a very important role in business analysis. Next slide, please. So mathematical programming, again, as operational research, involves a lot of mathematical programming. You have linear programming, network analysis, integer programming, nonlinear programming, and so on. Stochastic programming is also one that up there. Genetic algorithms are algorithms that are used to solve some of these problems. Many of these are implicit in data mining. Data mining actually uses a lot of neural networks and artificial intelligence, a lot of nonlinear programming. Those are all hidden under, but people don't talk much about it unless you read papers on what exactly is data mining or what exactly is neural networks, and only then you are really understand what is exactly going on. Decision analysis, game theory, and of course multi-criteria models are more difficult to solve, but that's all part of the mathematical work. Next slide, please. Now, with the large data, this is something, we always used to argue that, if you can optimize, you should do that, optimize instead of finding approximation. But with large amounts of data available, unless you are somehow able to reduce the amount of data, these algorithms take a little more time to solve and so on. So it may be difficult to solve. And of course, with these days of parallel processing, you have to really rework the algorithm so that you can use several processors at the same time. What I say is, for instance, decomposition, which involves several subproblems and so on, may not be so attractive if you're talking about serial processing. But when you have multiprocessors, you can give the different subproblems to different processors and get the results and then put them all together. So a lot of effort, you don't hear that much, but I'm sure people are using this parallel processing a lot, algorithmic development, computer science people who actually write the codes and so on, use some of these aspects which are not transparent unless you are working in the field. If you are one of the researchers in the field, you will know that. But if you are just looking at it from the business point of view, those things are not transparent. And heuristics also become important because with the large amounts of data, it's difficult to optimize always. But one problem with heuristics is how good are your heuristics and so on is not quite apparent. Although there are some heuristics which guarantee an optimal solution within a certain percentage and things like that. Now, the next interface is computer science, which involves now large data management. And of course, artificial intelligence is gaining ground now. I'll talk a little bit about that. And machine learning, which is actually involves a lot of nonlinear programming methods. Large data management in computer science is data structures, what are the different data structures, storage and retrieval of data, and use of cloud computing, and how effectively you share resources and confidentiality issues. These are all very important. These are all, might say, part of computer science. As I said earlier, if you view business analytics from a computer science point of view, you will be concerned about all this. If you view it from a multivariate statistics point of view, you will be concerned about those multivariate statistic methods that I talked about, and you will try to see which can be used and how with large data. The difference now is large amount of data that is available, and how you can modify your approaches with the presence of large data bases that are available. And if you are an operational research point of view, you look at it from an operational research point of view, you'll be concerned about artificial intelligence, nonlinear programming, algorithm, stochastic programming, and linear and integer programming, and those kinds of things. But if you are really talking about business analytics, you must be concerned about all three of them. Next slide, please. So large-scale optimization, I already talked about parallel processing. Now, artificial intelligence is gaining ground. What is artificial intelligence? It's a branch of computer science that attempts to create intelligent machines. Supposedly, machines are intelligent, they mimic human decision-making. Actually, not so much human decision-making, at least human thought processes and human approaches coming up with recommendations. My view on all of this is these are all tools and aids to decision-making. Although you might say they're making decisions, they're not actually making decisions. They're coming out with suggestions or with answers, and it is for the decision maker or the manager or whoever is going to take a call finally. So they're in some sense like aids to decision making. The aids may not be a good word. Let's say they help you in making decisions. So, according to some definitions, artificial intelligence works in 4 different ways. I think it's good to know this because part of computer science and it's useful, and artificial intelligence is now talked about as the future. So one is automated intelligence, basically automation of manual, routine, non-routine tasks which has taken place and is continuing to take place. And I think that will replace a lot of human employers and employees who do just routine tasks. So those kinds of jobs slowly but steadily are disappearing. Assisted intelligence helps people perform tasks faster and better. This is useful for people, and so it does not exactly replace human employees. Next slide, please. Next slide. So, more important is the augmented intelligence. This is very useful, helps people make better decisions. So, comes out with the recommendations, and ultimately you have to make decisions. Autonomous intelligence is automating decision-making process without human intervention. We are far from it. Although people talk about autonomous intelligence, I think we are far from it. You know, artificial intelligence people, computer science guys, always hype up the short run. As somebody said, artificial intelligence is all hyped up in the short run, but in long run, we underestimate the power of artificial intelligence. So artificial intelligence, you know, when I was a student at Carnegie Mellon University, the Herbert Simon, who later went on to win the Nobel Prize, he had predicted that chess, he was into computer science a lot, he predicted that chess will become a dead game, chess will disappear as a game in 10 years from now. That was, when I was there, it was already about 6-7 years, and it didn't look like chess was going to become irrelevant again. So my professor said, if you're going to make any predictions, make it well into the future. So by the time comes, you will be long gone, and if it is comes out true, they will hail you as the visionary. But if it doesn't come true, they'll forget it anyway. So you don't have to worry about it. So artificial intelligence, I think, in the short run, people are overestimating the capabilities, but in the long run, I think we are underestimating. The long run will come true. How long is the long? In the sense, in terms of chess, although chess hasn't become an irrelevant game, it was only in 2004 or 5 that the first program, I think Deep Throat or whatever it's called, with the Grandmaster chess. Still, chess is not becoming an irrelevant game. I think it takes a long time. So some of these will take much longer than what they are predicting, but they will eventually happen. And the problem is what is short term, what is long. But more importantly, automation and augmentation. Augmentation is what we want. Automation is slowly and steadily start doing what people do and possibly replace people. Okay, this cost saving limitation is that essentially it is restricted to present work. It gets automated. Augmentation is more important. Start with what humans are doing. Find out how the work can be deepened and improved rather than diminishing the work. So augmentation is very important, and I think the future artificial intelligence will be in terms of augmentation. Next slide, please. Next. Yeah, so in terms of analytics, you have all these different types of analytics which are there in business intelligence as well. Descriptive analytics, a lot of statistics, summary statistics, graphical representation. So, as with all tools, it can be misused, and there can be distortions in presentation. Choice of scales becomes important. Some small increments can be chosen to be big by choosing an appropriate scale. Large increments can be chosen to be small by presenting it in a different scale and so on. So I think one has to be careful how exactly these descriptive analytics are used. But basically, descriptive analytics are summary statistics. Prescriptive analytics is basically trying to find out what you should be doing, what is best, optimal, best decision. So a lot of optimization is involved. Good solutions, of course, now with large amount of data, heuristics become important. But then the question comes, how good are the solutions? In fact, many of these machine learning algorithms, you don't know exactly how good are the solutions. Comes through, forecasting techniques become important, forecasting errors and so on. So predictive analytics is perhaps the most difficult part of all the analytics, and how well the field progresses will depend upon how good the predictions are, how well the people are able to do this. And then, of course, you have functional analytics. For each business function, there is a set of analytics: finance, marketing, HR, strategy, and so on, operations. Each of those functional areas have their own analytics. Analytics are basically, I said, quantitative approaches involving multivariate statistics or optimization. Next slide, please. So big data is a problem. Analytics, we need to process large amounts of data. Machine learning techniques are being used. And then, of course, you cannot avoid web and social media analytics. How much you may not like social media and so on. You may be a fan, or you may be dead against social media, but you cannot avoid social media, because if you're an organization, even educational institutions cannot avoid social media, because you won't know what students or what your past students or your students of other institutions are saying about your institution, comparing your institution and so on. Social media has an important role, and even the websites, you have to be very careful of what is presented. And I'm told in the Google and so on, you can, I don't know whether there's some payment is required, but when somebody searches, your institution will come out on the top as opposed to be somewhere way down the list and so on. So these web and social media analytics, data mining, all are going to become important. Although we are not, this is a more recent phenomena, but I think more and more emphasis is required. I remember when I started at Dean at ISB, actually we did a lot of web analytics and social media analytics. wouldn't call it web and social media analytics, but at least we had people looking into social media and the web to see what they're saying about ISB, what are the customers, students talking about, and so on. And you have to also maybe even take part in that. Some of your own people must take part and say that you don't get bad publicity and so on. You have to be active in social media and the web. So, next slide, please. Some of these may look like it's not so important and so on. Some of us may really love social media analytics, some of us social media, some of them may hate social media. But I think as an organization, you have to be familiar and you have to take part in it, whether you like it or not. Machine learning is also, I already talked about, it's part of artificial intelligence. The algorithms are basically nonlinear programming. And basically, you get a sequence of, you keep giving data, train the machine. Machine means the software, embedded software, and you keep feeding the data, and you know what the actual output should be, and you compare the output from the algorithm or from the software to the actual output, and the machine is supposed to be learning just as human beings learn, and the algorithm modifies itself, meaning that nonlinear programming algorithm will change the parameters and so on, and come up with better estimates and so on. As you give more and more training data or data to software, and it learns by itself. It's supposed to be how human beings learn, in terms of you see something, you learn something, and then you see something else, and you modify your thought processes and so on. So that is why it's called machine learning. It's a machine, or actually the software is learning through data that sequentially provided to it. Now, one problem in this, all these people are not talking about it. If you are in a rapidly changing environment, it can be problematic. What you have learned, can I have the next slide, please? Next slide. So this is sort of what a neural network, and then I'll come to the thing. So you have input, and you have some hidden layer. Basically, input has various parameters and what weights to give, and then through the hidden layer, and then you come up with another algorithm. There are sort of basically two sets of algorithms, one between the input and the hidden layer, and then the other between the hidden layer and the output layer. And basically, you feed the data, and you come up with the output, and you compare with what the actual output should have been, and then the algorithm modifies itself and changes the weights and so on. So the next time you provide the inputs, it will come up with a better classification and so on. And so lots of input data is given, and hopefully the algorithm will converge to some set of weights, and the classification will be reasonably good. Next slide, please. So what is the problem? The idea, as I said, is machines are learning from experience and so on. Now, I always like to say that one has to be careful about past experience. I always say past experience is good, but experiences can be blinding also. If you think that what you have learned or what you have done in, say, in the 70s, 60s, 70s, it still holds good today. You know, whoever heard of web analytics and social media analytics in those years? You know, if you only think along those lines, it can be very misleading. So I always say experience can be sometimes be blinding. You have to be very careful. So nowadays the thinking is because of the job situation, the rapid changes in the environment, they talk about learning, unlearning, and relearning. So in terms of machine learning, I think what we need is you have training something, and then you have to detrain and you have to retrain and so on. I think this becomes important, because it's not just that you are trained and then you can set the algorithms and so on. But as things have changed in the past, so you have to retrain and you have to come up with retraining and so on. So I think this sort of thing people are not talking about, but I think it becomes very important in terms of machine learning. Next slide, please. So web analytics, you collect data from the web for designing the web, because you know, nowadays your websites are used so much, and there are all kinds of methods and methodology. You can track where the visitors to your website are, which location, whether if you are an educational institution, if a lot of people from one region are visiting your website, you can promote your school or your educational institution more in that area or more in other areas and so on. There's also what is called click analytics, exactly what the visitors to the website are viewing in your website, useful for advertising. These are all useful for advertising campaigns and gaining customers. Education institutions may not be looking at it from that point of view, but we are also have to start worrying about students and how well they are. We are able to attract students, how well they were able to place them. So, next slide, please. So social media analytics I already talked about, so I'll skip some of this. Basically, you have to be active in the social media, as Facebook, Instagram, LinkedIn, Twitter. You must have your own people also as members of that. And if you have to counter some of the negative publicity, some people might. So there may be one student who didn't like or what you did or something and may spread all kinds of rumors, all kinds of things about your institution. So you have to be very careful and you have to be present in this. And so. Next slide, please. So before I close, I'll talk about the business analytics program at ISB that gives you some idea of what is involved in a truly business analytics program. I find there's several business analytics programs, but they cover only certain aspects of the three interfaces I talked about, basically multivariate statistics. Of course, you have to talk about business, analytics for business. And besides that, the three are multivariate statistics, optimization, and computer science. Many of the programs will cover only one or two of them. But the business analytics course at ISB covers all three aspects. It's a modular certificate program. Modular means people come for 1 week or so, every 6 weeks, every 8 weeks or so, spread over a year and so on. So there's the pre-term courses, which are probability and statistics using R as the tool. And then Python, which is a computer science thing, is used also. They have to, these are all done before they come to the core courses. Introduction to databases are also important. Remember, these are all computer science and multivariate statistics are important. The core course will be business fundamentals. You have to understand what business is all about, and data collection, data visualization, text analytics. Next slide, please. So estimation, regression, and all the statistical analysis is covered, and optimization, simulation. These are all, as I mentioned earlier, multivariate statistics and optimization, large-scale linear programming, integer programming, and so on. Of course, we have to be concerned about big data management. One of the distinguishing features of business analytics is large amounts of data. So we should not forget that big data management becomes important. So data mining and deep learning, Internet of Things are also covered. Next slide, please. So application analytics, is the functional area because it's a course in business analytics. So you have to talk about marketing analytics, retail analytics, supply chain, finance analytics, human resource analytics, social media and web analytics are also covered. And there's a project and a capstone project and so on. So that is the course that covers all three aspects, as I've mentioned, including talking about the business and so on. It's a very popular course. A lot of people have attended and continuing to attend. Next slide, please. Next slide. So let me go with the concluding remarks. Slightly different from what I've covered, but let me do that anyway. So we had operational research. Started, of course, during World War, and although it may not have, it might evolved into slightly differently, not particularly for operations or for research, but in terms of quantitative approaches to decision making, analytical approaches to decision making. Then we had decision support system helping managers in terms of making decisions, and that is when, of course, analysis paralysis probably gained popularity, but that is all now dismissed, I think. And business intelligence, and then again, now it's business analytics. My question is what next? I don't know the answer. So I'm raising some questions. Business analytics, the promise of business analytics will depend a lot on what delivers in terms of predictive analytics. So far, it has been mostly predominantly descriptive and prescriptive analytics. Now, predictive analytics, they've started doing that, but not as much, and so the future will business analytics will depend on how good the predictions are, how useful the managers find in terms of predictive analytics. That is going to be the important. Now, slightly deviating from this topic, I want to talk a little, in concluding remarks, I want to say something about disruptive educational scenario. I think with this lockdown has just speeded up the use of blended learning, mixed both online as well as face-to-face learning, and I think it's going to gain more and more ground, and I think it's going to become very important in the future. Technological improvements in delivery of programs, I think technology is going to play an important role, and there will be large-scale improvements and so on. Now, people are saying, I don't know how soon it will happen or will it happen at all. If large technology companies collaborate with the universities and now start offering blended learning programs or online programs and so on, what effect it will have on institutions that offer only face-to-face kind of program. Some of them will disappear, they all have to move into blended learning. There's a lot of changes taking place in the US in terms of MBA education. Some universities have dropped the full-time MBA, not some, only one, I think, dropped the full-time MBA program, doing only online programs and so on. Others are also worried what will happen to the face-to-face kind of programs when the online program gain much more ground. And some predictions, of course, always, they say, in 20 years, higher educational institutions will be relics and so on. So, of course, they are all little, I say, far-fetched, but in the long run it might happen, but not in the short run, not in our lifetime anyway. So individual learning, I think people have started questioning our model of classroom of 60 or 70 and give them all the same material. So individual people learn at different speeds, different kinds of learning. Some of it is done in the high schools in the US and abroad and so on, and also in India nowadays. That is, you may be of certain age group, but you may be better in math, you may be doing some advanced math, you may be slow in something, history or something, you may be a language, you may be doing something lesser than some of the other students and so on. So those things are being done in school a little bit, but when you come to higher education, it still will not come to the individualized learning. We think everybody will learn at the same speed. We give the material and we discuss. Of course, we have different ways of discussing, whether case method or whether it is lecture method and so on. But individuals learn at different speeds, and so people have started questioning the approach of classroom approaches to learning and so on. Here again, online learning can be very helpful because you can, people can learn at different speeds, and those who are slow learners can be given additional material and added background material or introductory material. So that is, I think, going to happen, but how soon is the question. Teachers may become enablers of learning by the students, learning of the students, but rather than content providers. We have been, to a large extent, earlier, although things have changed considerably since, say, the last 10, 20 years and so on. Content providers is more slowly but steadily changing to being enablers of learning. Next slide, please. Next slide. So, in a dynamically changing nature, they all predict nature of jobs will change, and so people will have to, if you look at people will have, in their lifetime, will have at least 5, 10 jobs and so on. And so, what is required for jobs is adapt lifelong learning. Lifelong learning is always required, but adapt lifelong learning, you have to quickly learn new things, and that is going to be a challenge. And that's going to be a challenge for educational institutions also. Typically, educational institutions are slow in changing methodology. My professor at Carnegie Mellon University used to say, if you want to change anything in a university, it's better to start a new one. So these kinds of things are problematic, and changes are going to happen in the work environment. The whole concept of education is also changing, and fortunately or unfortunately, I think to some extent unfortunate, because learning for learning's sake is not being touted upon as much as it used to be before. Now learning is for all jobs. So if you learn something, how useful it will be to get a job and that kind of thing. That's the unfortunate part. I hope it won't become the only thing. Learning for learning will also hopefully will survive. But still the institutions have to change fast. The faculty have to change also. So does that mean that faculty will require more breadth the knowledge, especially you look at, say, business faculty. Now, if you are very specialized in only in, say, finance or something, you don't want to teach any other course like quantitative methods or marketing or some other disciplines. And I find faults with some of the university doctoral programs. They go more into depth, but they don't get enough depth in terms of especially business doctoral programs, business school doctoral programs. In fact, recently I went to an institution which had a very good business school and a lot of courses offered in the doctoral program. They have now become a university, part of a university, and the university program is more depth than breadth. They don't take no required courses to take and things like that. So I think it's going to become important that the faculty get more breadth so that the changes, they can also change quickly. It becomes palatable. If faculty don't change, institutions will not change, and you will have a serious problem. As I said earlier, impact of artificial intelligence will be there. It's exaggerated in the short run, but underestimated in the long run. But the real problem is how long is short run, and how long will it take for all these changes to come to fruition, or how far is long run is also important. As I think one of the economists or somebody said, in the long run we are all dead, so we don't know what long run is. So at the master's level, I think there'll be, at least MBA program, there'll be many more modular short duration programs. I think the MBA programs are going to change dramatically next. In abroad, it will change dramatically in the next 10 years. Probably in India, it will take longer. We are slow in changes. Sometimes the slowness is advantageous because you don't just keep changing for the sake of changing. But if you're too slow, of course, you may miss the boat. So you have to be careful. So there'll be modular short duration programs. So people are even talking about, say, the MBA programs may become 1 year programs, and not a complete MBA program. First, you have a 1 year program where you learn about business functions and so on, and maybe a little bit about the functional area that you are going to get a job in. And then as you progress in your job, you want to learn more, you will take short duration, these modular programs and so on. And you take and the organizers for inviting me to give this talk. Thank you.
Thank you for your nice presentation and so many advices to the present scenario in the government and as well as in the particularly in education side. Now I request anybody having 1 or 2 questions from the audience. Sir, Bijan Sarkar, please unmute.
I must thank Professor Rawada for wonderful deliberation, the inaugural speech. Beautiful that I learned today that learn, unlearn, relearn, the training, detraining and retraining. Sir, what is detraining?
Detraining means, see, you get a lot of data you're given, but if that data is still part of the software using that, so the changes will come about slowly. So basically you have to say discard all those that you have trained, all the data that was fed in, and now new data and start afresh. So detraining means if you still keep that data, so it will change slowly, but it will take a long time to change. See, you need a swift change, not a gradual change. If it's a gradual change, that you're using past data, slow, new data is fed in, it will keep changing, but slowly the new data is coming in. But if you don't have the new data at all, and old data at all, only the new data, the changes will be much faster. That's all.
Okay, thank you very much. Thank you. Thank you.
Thank you, sir. Since of running time, so thank you very much, sir, for Marrao Garu. So the next speaker is Professor T.S. Ardhanari Garu. So I am happy to introduce Thiru Ardhanari is with Faculty of Business and Finance, the University of Auckland, facilitating teaching, contributing to the research environment through his doctoral supervisions Publications and Services at the Department of Information Systems and Operations Management. He is specializes in the optimization of complex problems in supply chain operations. Thiru was awarded the International Anaslius Award, Renato Colapso Prize for Mathematics, instituted in honor of the 20th century Italian geometer Renato Colapso at Rizigo, Calabria, Italy in 2014. He received the Lifetime Achievement Award from the Operational Research Society of India, ORSI, for the outstanding contributions towards the promotion of operation research in India. He has international recognition for his research showing most statistical problems are essentially constrained optimization problems. This work appeared as a widely classic book, Mathematical Programming in Statistics, co-authored with Y. Dodge. Thiru is a fellow and life member of the Indian Society for Probability and Statistics and a fellow and life member of the Operational Research Society of India. Thiru Ardanari is an adjunct professor at C.R.RAO Advanced Institute for Mathematics, Statistics and Computer Science, Hyderabad. He was elected as a corresponding member to the Academia Valoranta di Spirituality, established in 1729 in Sicily. He received the Best Paper Award in 2016 for his paper published in Journal of Age. Recently, Thiru received the Best Research Excellence Award 2017 from the Business School, and he has published several international journals. His articles were published in several international journals: the Journal of the Association of Information Systems, Journal of International Journal of Production Economics, International Journal of Operations and Production Management, Discrete Mathematics, Discrete Applied Mathematics, Annals of Operational Research, European Journal of Operation Research, and others. His research interests include robustness of supply chain design, robustifying supply chain performance, combinatorial optimization problems relating to the container port operations, 3PL value added services, and sustainability implementation in universities. Applied studies by Thiru include refinery blending and production scheduling, electrostatic precipitator design, dynamic balancing of power plant, exhaust fans, silo sizing in a fertilizer plant, understanding factors of the false alarm, and several other quality improvement problems and cutting stock problems. So now I request Professor T.S. Ardanari Garu to speak.
Are you able to hear me?
Yes, sir. Yes, sir.
Yeah. Hi to everyone from Auckland, New Zealand. At the outset, I must thank the organizers for giving me this opportunity, especially Professor Reddy for his untiring efforts. And so I want to present this talk in two parts. The first part, I want to say how Professor Rao has played an important role in my life. And then I go on to talk about the importance of pedigree polytopes, a study that I have been doing for a long time, and now I got a very interesting result, which I would like to share with you. I hope I'm able to show you the slides now. Are you able to see the slides?
No, sir.
Yeah. Not able.
No.
So how do I do that? Present now. Are you able to see?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Yes.
Okay. Hello from Auckland. I'm very glad that I could participate in this webinar. The first part, as I said, I'm going to recollect some of my, in my life, what C.R.RAO has played the role. Actually, I joined the Indian Statistical Institute in 1965. As every student is asked, they ask questions relating to gambling, and I come from a family where gambling was never allowed. We were not allowed to play cards, but my father used to play a game, which is strategy game called Adupuli Autumn. I think it has different names in Telugu and Kannada, but it's mostly prevalent in southern part of India. And anyway, I could get in because I did have a degree in BSc in statistics. I have learned some gambling there. And then the year 1966, we were supposed to have a specialization to be chosen as part of our MSTAT program. We, three of us, we went to Professor Rao and we said we would like to do operational research specialization because such a specialization was not given in ISI before. In 15 minutes time, he just talked to us and then he said, yes, it will be done. Within, I think, 2 weeks time, a course was put together. We were taught game theory by Professor T. Pasasasi, graph theory by Professor U.S.R. Murthy, and he also taught us linear programming, and dynamic programming was taught by Professor Ashok Maitra, and stochastic process and applications were done by Professor J. Sethuraman. Market research was taught by Professor Lakshmi Menon from IAM. And we were also asked to do operation research project. We did one project under Professor Subit Chowdhury, one of the founders of Operation Research Society. And also we did two projects under Professor Mahal Nobis. That's how our OR, program was started there. And these are the three people, myself, Achyutan, and Himanshu Kar. We were the three people who did this Operation Research program. Between 1967 and 70, after finishing our master's and also a diploma in Operation Research, which I actually worked on game theory, Professor Rao said, you cannot be a student of OR unless you do practical operation research. So he said, I'm going to send you to Chennai, the Madras SQC unit, and we must find some operation research problem and solve. I think that was a very great turning point in my life. Actually, from theory, I could take something to practice and solve some problem. And from practice, I could get some interesting research problem and I could do some research on that. I can, of course, give several examples. For want of time, I'm not going into the detail. So the basic idea was solve the problem at hand, get a new problem for research. And this was the way it was going on. And between 71 and 76, Professor Rao had given actually another important way he has played in my life is that he organized a series of seminars on numerical taxonomy. And looking at those problems actually inspired a chapter on grouping in my thesis. Actually, before that, I was working mainly on sequencing problems, scheduling problems. But this interest, I added one more chapter on grouping. And some of the algorithms I developed there are now used in artificial intelligence. And Professor Rao also had, of course, everybody knows Professor Rao's contribution to orthogonal arrays. And of course, it's some generalized ideas about Latin square designs, etc. And this actually became my major interest, that is combinatorial problems. And Professor Rao visited us in Tehran when I was working for the School of Planning and Computer Applications. It's another SPCA, but not the one dealing with animals. And in that school, one day Professor Rao was to give a seminar, and he went to the seminar hall, and then he didn't give the seminar because he didn't find me, because I was with Mrs. Rao going for shopping. So he gave the lecture the next day, and I attended the talk. And that night I worked on the problem he talked about. It is from a problem which Professor Desraj has handled, and it's about integrating surveys. And that became part of the book which I wrote along with Professor Yadullah Dodge. And the integration of survey we show there as a transportation problem, that is use of operation research there or mathematical programming in statistics. So that work, which actually Professor Rao gave the forward, he tells all statistical procedures are in the ultimate analysis solutions to suitably formulated optimization problems. And this book did very well, and it came out later as a Wiley classic book. And in fact, I would say some of these ideas which are in the book, paved the way for, I would say, bringing in a non-statistical approach to statistical problems. And in 2001, I could meet Professor Rao in a conference in Seoul, where I had an interesting topic to talk about, that is learning an optimization problem? As you would have noticed from Professor M.R. Rao's talk, many learning problems, machine learning problems, are essentially optimization problems. My question is learning an optimization problem? And which actually is a deep question, because we need to know, can we say all learning have to be optimization problem? But that question I'm still having in my mind. And of course, it prevented me from writing another book along with my co-author, because I had this question in my mind. I didn't want to continue the same way. And later in 2005, Professor Rao was invited to the University of Auckland. At that time, I was in the Department of Information System and Operation Management. It used to be called by a different name at that time. And this visit was also very important in my life, because he also talked, gave a lecture on multivariate data analysis to my class. Actually, he talked about cross-examination of data, which is very important, which is what I think Professor M.R. Rao also was telling, that a large amount of data is available, but without scrutiny, if we use them, we may not be getting palatable suggestions. So that is the topic he talked about. But any interesting thing, what happened was he has to go back to US because he was given the President's Award. But in the meantime, he also helped, we were creating a three-dimensional robot which will be able to answer questions from the students when the teacher is not available. I mean, this kind of robots are now used in marketing and many other places in some of the universities. And this is my student. Of course, he didn't complete his PhD because he could find a business. So he left. And Professor Rao actually gave a list of questions and answers in statistical inference for use by this robot called Maria. This Maria is supposed to help students in statistics. And Shaheen is having his own business now in creating such robots. And in many conferences, I have the opportunity to meet Professor Rao again and see the different dimensions of Professor Rao, his contributions to game theory and other areas. And it's always inspiring. And I should mention, it's always Mrs. Rao, whose hospitality we always enjoyed. And I should mention this as well, that when Professor Rao visited Tehran, Mrs. Rao actually used my small kitchen and gave a feast to many of the Iranian statisticians. And Rao has got very interesting childlike wishes. I used to have a motorcycle like this one, but it's not mine. And he wanted to have a ride on the motorbike as a pillion rider in a very busy street in Chennai near Gemini Circle. And he enjoyed that ride. And he's also a great photographer, actually. Many people may be knowing it already. This picture is actually, he has asked his daughter to pose like this statue here. And then when we visited him, he asked my daughter-in-law to pose like that, and he took that picture. This picture is taken by Professor Rao. And Professor Rao is an art lover, and he used to encourage B.R. Panesar in his artwork. And B.R. Panesar used to actually like my collages, which I made first time in ISI. And he asked me to submit it to the All India exhibition. What was more interesting is Professor Rao and his family and many from ISI came and encouraged me. And here is my latest collage. This is a collage of my mother, and it is very fitting that it looks like she is appreciating Professor Rao in the centenary year. And at the home front, he has participated in many of my household, like my daughter's wedding, and he's actually carrying my grandson and many other occasions. So he's like a father figure for me as well. Thank you, Professor Rao. And with this, I conclude the first part of the talk. And now I will be going to the second part, which is about importance of studying. Are you able to see the screen?
Yes.
Yes, sir.
Okay. So I felt, I must first say these few words about Professor Rao. And then, of course, now I'm going to talk about something on which I have been working for a long time, a problem called the pedigree polytope problem. I mean, this talk is going to be different from what Professor M.R. Rao was doing. It will have some amount of theoretical. This one, I will try to keep it as minimum as possible and tell the story rather than proofs and other thing. But if I do use some symbols, please excuse me. And so I will explain what are pedigree polytope and why study polytopes, etc. So why study pedigree polytope? In fact, polytopes in general are very interesting objects. Polytopes are very simple things, like, for instance, if you have a square or a cube, that's a polytope. And polytopes have got extreme points. And then you can talk about whether a point is inside the polytope or not. And these kind of questions are interesting. So this is a quotation from Ziegler, and he has an interesting book on polytopes. So we'll need to know some. In this talk, I'll talk about some of the things related to pedigree polytope. I need to tell what pedigree is. I'll come to that. Then the adjacency in the pedigree polytope, I'll explain that too. And then membership in the pedigree polytope. And then at the end, what is the implication of studying this? I will be doing conclusion and future research. Polytope, the name was given by Alicia Boole. Everybody knows about George Boole with respect to computers. And she gave this name polytope for such objects. I don't want to go through all the detail. We generally have an idea about a convex set. And the convex hull is that if you have the extreme points and then you take the weighted, some giving positive weights adding up to 1, that gives you convex combinations of the extreme points. And the convex hull is actually the set of such points and minimum such convex set actually. And convex polytopes can be also given in terms of linear inequalities. That means if you give a set of linear inequalities, you will be defining a polytope. If it is bounded, we call it polytope or polyhedron, things like that. Okay, this is a simple example. For instance, this triangle has the 3 extreme points and the convex hull is the blue part, and you can also write it in terms of these inequalities. I will now, to give an introduction to pedigrees, I will talk about this insertion operation. And this is something well known in when you study say problems involving say like tours in case of traveling salesman problem. We can start with a simple 3 tour, then add by inserting other cities one by one, we can get larger and larger tours. So this idea is used as a heuristic in solving traveling salesman problem. So for instance here 1, 2, 3, that's the tour if you have only 3 cities. And if I'm only going to talk about symmetric tours, then it is enough because that's the only tour and that will be optimal. But if you want to consider more number of cities, then what you can do, you can choose one of the edges. Here I have taken 1, 3. I can insert 4 into that. That will produce 2 more edges like this, 1, 4 and 3, 4. Now we are getting a 4 tour. Now you can continue like this. You can insert 5 in one of these edges and then 6, etc. until you get the n tour which you are interested in. This idea of insertion is already known, but the idea of pedigree comes from this. So the edge that is chosen to insert 4 is my first component of the pedigree. Then if I choose the next edge for inserting 5, that becomes my next component in the pedigree. So this is like instead of studying tours, we may be able to study pedigrees. But this makes a big difference because all the algorithms so far, what you can see in the literature, they all work with twos and then try to improve upon twos, etc. Now, here we are deviating from that. So you can understand the pedigree concept is just whichever edge you have chosen to insert 4, 5, 6, etc. Those set of edges in that order, they become the pedigree. So you can see that now I'm animating that. See, 5 is 5, 3, 4. Then of course, if I insert 6 between 2 and 3, I get the next component of pedigree, and 7 like that. Now I can also any of the face of the polytope, which is defined by the sum of these edges. And you can also talk about, given a polytope, the one skeleton of the polytope. That means only consider the vertex and the edges. And that is called the graph or the one skeleton of that. So we can ask the question, given 2 vertices, are they adjacent or not? That is, in this graph, are they side by side? That means they are connected by an edge or not. So this question is an interesting question. And this is called the testing adjacency on polytopes. So given 2 vertices polytope, we want to know whether they are adjacent. That means is there an edge connecting the two? This problem is important for traveling salesman problem as well. And we have some interesting results. With respect to STST, we know from the work of PADMA and that testing whether two tools are non-adjacent is NP complete. It is as solving the traveling salesman problem. Okay, so it's interesting to note that even just testing whether two tools are connected by an edge is a difficult problem. But what I have shown is that if you give me two pedigrees, testing whether they are non-adjacent can be done very efficiently. You can actually do with a very simple algorithm, which works, like n power 3 kind of thing. So this is a big difference between working with tool polytope, which most of the research is being done, than working with the pedigree polytope. Because now we see that it has some property which is not there, shared by tool polytope. Actually, I can skip some of these details, and we'll go to the results so that I don't burden you with trying to understand notations and all. So what I have done here is, how do I find given two pedigrees whether they are adjacent or non-adjacent? For that I proved an interesting result. So here I take two pedigrees. One is the white one, the other one is the red one, and the corresponding tools are also shown here. Now, if you compare the component white, you find that they have the same, or they have different. Now, if they are same, we can ignore them. Only we need to consider that they are different. Now, here only one of them is different. In the white one, we have 2, 6. In the pink one, we have 4, 6. So this means there is only one discard. Whenever you have only one discard, that means those two pedigrees are adjacent. So this result helps us in identifying that without that. Okay. So I also do how to do in general what to do if it is not one discard, there are more than one discard. I prove the following result. I define what is called a graph of rigidity. We show that connectedness of the graph indicate the pedigrees are adjacent. So if this graph is having more than one component, then it means that they are non-adjacent. Okay, so that's a result. I'm not going into the proof of that, but it is very easy to apply this result and check whether any two pedigrees are adjacent or not. So I will skip a few slides and go to the I'll go to the next slide here. What is called a combinatorial property of 0-1 polytopes. And this is defined by Nadef and Coulibaly. And what it says is that if you are given two non-adjacent vertices of the polytope, for combinatorial property, if it is there, you will be able to find two other vertices such that the sum of the first two vertices is equal to sum of the second vertices. Okay. So this is an interesting property. There is something like if you draw a line between okay. I'll skip a few more slides and go to the next important thing. The history of traveling salesman problem, you can actually get a very interesting account from book. Yeah. William Cook has got a book, Information, Computation and Optimization. It covers the history of PSP, and it also talks about Professor Malnovis' interest Let me skip a few more slides because they contain a lot of symbols and everything. I've come to the important question about complexity. Of course, Apple's have played an important role because most of you today you have a smartphone, which is a computer, and Apple computer was one of the first personal computers that were made, and there are many Apples in the history. But Alan Turing statue here, you can see he's having an apple in his hand, and this picture is what is important for me because I'm going to talk about Alan Turing's work. He actually is credited with this important thing, what is called a computational model for computers. That means it's a simple model, but it's as good as any computer that we are using. So if you want to classify problem, difficult problem, simple problem, etc., we can actually use this model and see whether something can be done easily or it will take enormous amount of time. Since I need to quickly take you through the material, I will say a few things which you all must be knowing already. The complexity, we measure in terms of whether you can do it in polynomial time or it will take exponential time. So in this picture you can see as long as it is a polynomial one, the growth is not that steep, but if it is exponential, it grows very fast. And that's why good algorithms we are looking for difficult problems. And Professor Rao mentioned about many problems in operation research which are considered to be hard to solve. But practically we are solving such problems every day, but not necessarily to optimality. And sometimes we don't need them. But the theoretical question is, are these problems really difficult, or can we find a better algorithm for some of these problems? So that is the burning question. So computational complexity occupies computer scientists, operation researchers, mathematicians for a long time. and some problems are still not yielding. And one such problem is the traveling salesman problem. Now, what I have done recently is that I have shown that the membership problem or membership checking problem for pedigree polytopes can be done very efficiently. This opens up a new, I think, a number of new possibilities because of the implications of this. So instead of going into the details of how I did that, I will again skip a few slides and just tell the result. So here I have a flow chart which can be used to check, given a X, whether it belongs to the pedigree polytope or not. Actually, these steps are going to involve only solving some flow problems, like a bipartite flow problem, which we call forbidden arc transportation problem. Because in the bipartite flow problem, if some of the arcs are not allowed logically, we have the forbidden arc transportation problem. So we solve such problems in that, and we solve some maximal flow problem in some networks. We also solve, sometimes maybe we have to solve a multi-commodity flow problem. All these problems fall under the category called combinatorial LP. And we have an interesting result that says combinatorial LP can be solved in a strongly polynomial time. That means very efficient. So this is the main finding. I do have some examples to show how it is done, but I think for want of time, I won't go through that, but I will just show you the last result. So given a solution X, which is already satisfying some constraint, we can check efficiently whether that X belongs to the pedigree polytope. You may wonder, so what, okay? So that's what I'm going to show you next. The importance of this comes from the work by these three guys. They have done a remarkable job of showing polynomial time equivalence of optimization problem, separation problem, and membership problem. And they use, of course, Kachian ellipsoid algorithm, which is given for linear programming, to show that linear programming problems can be done in polynomial time of the size of the input. So with what I have recently obtained, and with this result, it means a lot. That means many of those difficult problems can now be solved in polynomial time. So if you have any questions, I would like to take them. I'm really sorry that I have to take you through some theoretical material, but I thought it's a very great occasion where I should share this important finding. And these are some of my students who had worked with me in different other related areas. And this is Professor Usha Mohan. She is at IIT Madras. And this is Lale Haydian. She is in Ontario she's working with McKinsey Investments, and Kun, he is working with Amazon in Australia. And of course, now we are all worried about coronavirus and computing industry. They are expecting a lot of glitches, like what we saw at the Millennium glitch, but Turing machines have no problem. With that, I'm ready to take your questions. Yes? Any questions?
Yeah, Palani.
Can I just ask a question?
Yeah.
The diameter of the traveling salesman polytope is 2. What is the diameter of this pedigree polytope?
Actually, I have one paper in discrete optimization, which actually shows whenever you have two pedigrees non-adjacent, the corresponding tours are also non-adjacent. So from there we can actually get some bound similarity.
Thank you.
I should apologize to everyone if it was too much of a theoretical one, but it's a very interesting result. I thought I should share.
Yeah, any? Okay, if not, okay. Okay, thank you, sir. Thank you for all your firing speech about what. Okay. And I am sure that this book, Mathematical Programming in Statistics, while I was traveling with Prof.C.R.RAO one day to the airport of Tirupati, he suggested me, because Rajshekar, you did mathematical programming in statistics written by Centenary. So I came to know that this book, then I bought this book, I brought to my friend from a library. Then I gone through this book. It is a very wonderful book. Thank you very much, sir, Centenary, for all your support towards our statistics and our war. Thank you. Thank you.
Thank you everyone. Thank you.
Now,
FPS or AWARDEE. Thank you so much for hosting and inviting me to the class. It gives me pleasure to introduce Professor Chakraborty, a next speaker. Dr. Chakraborty is a PhD analyst at the Indian Institute of and PhD from Indian Institute of His research interests within quality and reliability, particularly in software reliability. Recently, some of his students are working in the interface area of solid-state communication. He is currently guiding few students. He has published 3 books and is writing further books with HUMAN and multivariate process capability analysis. He also contributed chapters in many books. His first book was published. It was on ISO 9000. He has published more than 100 He served as an honorary member of the
Sir, click on that you are presenting, sir. Sir, not right click, sir. Just make a left click. Stop presenting.
Okay.
Thank you. Thank you, sir.
So, Professor Chakraborty, please.
Yeah. Thank you, Professor Akil Ahmed. I think we have met sometime back in Kashmir itself.
Yes.
It was a nice meeting and probably a good opportunity for me to go around Kashmir at that time.
Yeah.
So I must thank you for introducing me, and also I must thank Professor Rajsekhar Reddy for organizing such a conference at difficult times. Obviously, because the issue is about celebrating the birth centenary of Professor Rao. So I just start with a few words about Professor Rao. Though by the time I came to ISI as a student, Professor Rao had left by that time to US, and I could actually attend 2 of his programs, one in Chennai, in university, and another one in 2008 in Calcutta itself in ISI. In both the times, actually by came back with a very good lesson of two things. One is about life and the other one is about teaching. The first one was in Chennai when he gave a popular talk. And in fact, Professor Arthanari is here now. So myself, Professor Arthanari and Professor G.S.R. Murthy, three of us went to listen to that talk in Anna University. And he gave beautifully a lesson that how to look into the basic data before going into the analysis. In fact, he asked all the people who were attending the program to talk about how many sisters and brothers they have. And then he came to the conclusion that, you see, because it's already a biased population, because most of the people who were attending were gents, okay? So the basic population is biased, so obviously the number of boys and girls of that population will be a biased population towards the gender, male gender. So he said that by taking up this population, if you analyze whether it's 50-50, you won't get it because it's already a biased population. So that I learned how a very simple example he just used to say that before going into the analysis, you should know what is the data. The second one was about life. The second one was in 2008 when he came to ISI during our Platinum Jubilee celebration. Again, he gave a popular talk, and obviously when he gives a popular talk in ISI, there were a huge crowd, and some people went to the first floor of the auditorium standing. So after the talk, one of the students from the top floor, first floor, asked him a question, said, how come you are still active at this age? And he gave a nice reply, I still remember that, with a mischievous smile. He said that, I keep away from my wife. So I don't know whether that's a lesson, I don't know, but I got a lesson, right? But I don't practice that, that's a different thing, but it's a good lesson. So, so these are the two incidents I just thought of sharing with all of you, that, the interaction with Professor Rao. I really didn't have much of interaction with him because of geographical locations and things like that. Of course, very recently there were a lot of celebration of his birth centenary. I was present in some of them, but obviously did not get an opportunity to speak. So I thought this is a right opportunity. Okay. Now coming back to the presentation, how do I can share?
You can share it. Present now the entire session.
Yeah. So is it all of you can see this?
Yes. If you just share it, we will see it.
Yeah, I have shared.
But it's still to come. You press present now the entire screen. Mr. Venkateshwaran, please just look into it.
Sir, at the right side bottom, you can see that option, sir.
Yeah.
Present now. Right side bottom. Present now.
Present now, yeah.
Your entire screen.
Entire screen, press it, please.
Share your entire screen, but that share is not coming.
No, you click on that screen, sir. You select the screen, then you click on that share.
Put your cursor on the present now, please.
Now it's shared. So now it should be okay. Is it okay now?
Yet to open.
Click on the share.
Yeah, I have done it already.
You please redo it. It's not coming.
Okay.
Sir, present now.
Present now.
Sir, again, you can select entire screen, sir.
Yeah, I have done that.
And you will
Again,
get
click the entire screen.
I have done that.
One screen will be displayed, sir. Again, you can click that screen, sir.
Yeah.
Then click on share.
Click on share.
Yes, now it's coming.
Now it's coming, sir.
Now it's coming.
It's coming. Please go ahead.
So now it's okay?
Okay, sir.
Yeah, sorry. So this is actually based on a recent work that one of my students is working, and actually I'll start with a nice story here. The story goes back to 1998, and I was then in Chennai as head of Chennai unit of ISI. And because I was head of the unit, I was given a landline. There was no mobile, obviously, at that time. So I was having a landline at my home. And one day when I was sleeping in the dead of night, I got a call. And obviously I was really worried, because in the night time, if you get a call, you are not happy. Most likely it could be a, dangerous news. So because it was landline, so it was ringing, so I was forced to come from the bedroom. It was in a different room, obviously. So I came and picked up the call, and then I found that somebody started speaking in American English. So I was quite sure that it must have been a wrong call. So I was about to keep back the phone, but then the person on the other side called me by name, and then asked whether you are Dr. Chakravarti. I said fine. So when he called me the name, then I thought, even though I don't know anybody in US who speaks US English at that time, so then he said that, you see, we have a problem. Can you please solve this problem? And he gave a very interesting problem. Those days, I did not know how to solve immediately, but the problem was very interesting. The problem was that he had sold some, marketed some products in one of the US cities, and collected all the information of the people from that particular city. And also he knows who actually purchased that product. So being the first city for their product, launching their product, they had spent a good amount of money on marketing. But then his problem was that he is going to the next city. And suppose this data is given to me of the first city, and the information about the population of the second city, then can I find out that who are the people who are going to, most likely are going to buy their products. So the problem seems quite interesting, but obviously I said, yes, we can do it. But then he said, he asked me what kind of methodology you will use. Obviously, I was thinking about statistical methodology, but definitely because I have come out of my deep sleep. So I didn't want to share with him what kind of methodology I use. And normally in ISI, we have been taught that when you, as I said also, of PROF.C.R.RAO's lecture in Anna University, that don't go into the methodology first, but first try to understand the data and the problem. So these two, once we are able to understand, then probably we'll be able to find out an appropriate methodology which can be used. And both Professor Mahalanobis, Professor C.R.RAO, all of them actually, through their works, they have shown us that once you start with this kind of approach, there are many new problems that come for which solutions may not readily exist, and we may have to do some research on that. So I took it up as a statistical problem, but then finally the problem did not come to us. He asked me repeatedly that what kind of methods we will use, and I repeatedly told him that I'm not able to give you right now what methodology we'll use, but definitely we can solve it, even though I did not know how to solve it at that time. But subsequently, I have discussed with Professor J.K. Ghose, who is also a very well-known statistician. He's also no more now. To how to find out a solution to this statistically. Well, that was 1998, which later all of us know that that was the beginning of data analytics in US at that time. So what is data analytics? And my talk will be restricted to only hybridization of statistical machine learning methods in data analytics. This is what actually one of my students is working on. I will come to the example which actually motivated us to start to work on this. That example I will come to later. But I could relate it to the problem that had been given to us or had been told to us in 1998 itself. We'll see the similarity when I come to the example. So data science, what is basically, now most of the jobs that people are going for, whether it's from different universities or even in ISI, the job is in data science. So people are in the industry, in the organizations, people are looking for data scientists. And most of our students are absorbed as a data scientist. Now, what exactly it is? So data science, there are many universities, many institutes and organizations. They have started programs in data science nowadays. And obviously some of the institutions already had a program on data science. Some new universities are starting programs on data science because that's the order of the day. That's what people would like to have. So this basically combines several techniques of machine learning and statistics. So statistics is the universal tool of inductive inference, research in natural and social sciences and technological applications. Therefore, it must always have purpose, either in the pursuit of knowledge or in the promotion of human welfare. So this is what Professor Mahalanobis has told long back, who is known as the father of statistics in India. The role, the role of statistics is in making inference from samples, and we know that there is a big history of Indian statistics, particularly in sample surveys. Then development of new methods for complex data sets and quantification of uncertainty and variability. So that is what basically we do in statistics. Now in machine learning, what we do is a field of study that gives computers the ability to learn without being explicitly programmed. So Professor M.R. Rao had already explained to some extent what machine learning does. So the role of machine learning is efficient algorithms. A lot of people are working on this to solve an optimization problem, represent and evaluate the model for inference, and create programs that can automatically learn rules from data. So this learning is from the data itself. So that's a big change in the technique itself. Well, Niels Bohr had said long back that prediction is very difficult, especially if it is about the future. And that is what even Professor M.R. Rao had mentioned, that now we are talking about predictive analysis. We like to predict. And there are many things that we have to do, particularly with respect to the nature. We like to predict what is going to happen tomorrow and things like that. So these are possible nowadays with the huge amount of different kinds of data, and the data has become huge. So there are techniques now being made available for big data. So if we look at the broad classification of the techniques, so on the right hand side we can see that there is a supervised learning techniques in which we can broadly classify the problems into either a classification problem or a regression problem. In the classification problem, we have something like a medical diagnosis, the spam detection, image recognition. These are classification problems. On the other side, if the output turns out to be continuous type data, then we have regression type of problems. So where again we have supervised learning techniques, and the application we can see in price estimation, process improvement, weather forecasting, etc. Some of the applications we have done in regression also for process improvements in some of the ITC companies, paper making companies, where we are working some time back as a consultant. Now similarly we have on the other side, on the left hand side, we have unsupervised learning techniques where obviously the first thing which comes in the classification type of problem, we use clustering analysis or clustering technique, and there the application we see in social networking, image segmentation, topic modeling, etc. The other side we have reinforcement learning, which is actually being developed nowadays, and it is basically strategy designing. And here we have robot control, beating games, bots, etc. These are some applications of reinforcement learning. Now here, let us take the example of credit scoring. So it is differentiating between low risk and high risk customers from their income and savings. These are just two parameters. There can be several parameters, obviously. And obviously these are very useful techniques nowadays, and there are a lot of banking industry and other industries which are using this to find out who are good borrowers, who are bad borrowers, in the sense of low risk and high risk, as far as the bank is concerned. So the discriminants can be done if the income is greater than some value θ1 and savings is greater than something θ2, then we'll say that it's a low risk, else there's a high risk. So that kind of classification, this just is a simpler example. So if this is the kind of classification, probably there could be a linear, non-linear separator using training data consisting of input-output pairs that we already have. So what we do normally is, from the set of data, we take about 70-80% data separately as the training data, and the model is built based on the training. So in the training data itself, we have input and output, so we know the values of income and savings, and we also know whether those people had paid their money back or not. So from that data, the model is built up. So, and then once the model is built up using the training data, which is about 70 or 80% of the total data sets, use it to predict the levels for the new test inputs. So that's how the model goes. as we have seen earlier also, the other applications could be in image recognition, spam detection, medical diagnosis, etc. And the picture on the right hand side is quite clear. Here we can have a separator like this in blue, which separates the low risk people from the high risk ones. And in this case, the problem is relatively simple, but real life problems are not that simple, as all of us know. On the regression side, another very simple example, say for example, price of a used car. And suppose X is the car attributes and Y is the price, then Y is a function of Fx and theta. And F is the model and theta is the model parameters. And we can use a regression kind of technique here, again using a portion of the data as training data with the input-output pairs known, and then try to predict the outputs for the test inputs. The other applications are price estimation, process improvement, weather forecasting, as we have seen earlier. Well, in clustering, we can see here the picture. Here, this is the picture, this is the original data. We do not know what it means, what it signifies. So, in such cases, probably clustering can help. And we can see here, using the clustering techniques, we can find out different groups. So probably we get some information about the data once we know these groups. So other applications are topic modeling, image segmentation, social networking, etc. Now, designing algorithms that ingest data and learn a model, that is what we do in predictive data analysis. The learned model can be used to detect either patterns or structures or trend, etc. in the data, and then make predictions about future data on the basis of which we take some decisions. And the predictive models obviously are data driven now and optimize the performance criterion using example data or past experience. So there is an optimization problem inside all these things. So in machine learning, what we do, as we have already seen, that it could be supervised learning, it could be unsupervised learning. And there are various methods in unsupervised learning, like K-means algorithm, etc., hierarchical process, Gaussian mixtures. All those things are unsupervised learning, neural networks, etc. In the supervised learning, we have classification. For the classification problems, we have support vector machines, discriminant analysis, naive Bayes, nearest neighbor technique, etc. In the regression part, we have linear regression or generalized linear models, support vector machines, SVR and GPR, ensemble methods, decision trees, neural networks. So these are various techniques as such that normally are being used for supervised learning under regression problems. These are just to give some examples where things are being used heavily nowadays. Say, for example, online fraud detection. If this can be done really online, then many of the frauds that we are suffering from now in India could have been avoided. Then predictive policing, well, that all these things depend on, as Professor PROF.C.R.RAO had already indicated, that it depends on how reliable are the data. So we can see that if the data are really reliable and the data sources could be very many, it's not like a simple data that we used to collect in our student days in the industry. The data are now in the form of image. The data could be in the form of satellite pictures and things like that. So obviously the data type and size has increased, and hence the different kinds of models need to be tried out to solve that problem. Similarly, spam detection and various other kinds of problems can be. A lot of new applications have come of this kind of techniques that we have already indicated. So machine learning algorithm also can learn to translate text. So for example, if we are given the English sentence, welcome to this course, the corresponding translation in Hindi or any language can be done using the machine learning algorithm. So those are now available. Even it can translate speech in real time. So that's an advantage of machine learning nowadays. So automatic generation of text captions for the images. Say for example, if we are given this image, so this is the input image, then there are various techniques that can be used like convolutional feature extraction, which most of the people from the computer background will be able to do it very easily. And so this is the first step of processing, and then the second step of processing is done, then LSTM is used, and finally we can really get this kind of answer, a bird flying over a body of water, so which is the picture. So once the picture is given, all these techniques can be used and analyzed, the data taken from this picture, and finally the answer in this form can be obtained. So that's a great thing, that's a great solution technique that we have nowadays. And similarly, a recommendation system, it's again a machine learning system that is based on data that indicate links between a set of users and a set of items. This we see that, for example, once we buy a cover for mobile, immediately, probably if the mobile number is known to them, a lot of information comes about new mobiles that are being marketed and things like that. So that's because of the recommendation system is already developed. So related products, they start giving you the information, and then if you buy a car cover, the various car companies will come and information comes about the various launches of different new types of models, etc. So that is the recommendation system. Again, it's a machine learning problem. So these are various kinds of techniques in machine learning which are being used. In fact, this is a very recent paper in Science in 2018, where machine learning algorithms are used to understand properties of molecules and learn to synthesize new molecules. So this basically gives us an idea that is not just statistics alone, but probably machine learning has been developed separately by the computer scientists mostly. But then there's a good book. I'll just show you that. All of Statistics by Larry Wasserman. This was published in 2004, and this is one of the books that Professor is using in teaching the course in statistics. And I've seen that here, probably for the first time in 2004, Professor Wasserman has used the basic concept of statistics and machine learning, though it's developed separately, many of them can be connected together. And in the book, he actually, in the course also, he does in the same way. Coming back here, yeah, As we have already seen that it helps in image recognition, we have seen that. It has many uses in biology, as I have told already in the paper in Science. Obviously, in the share market analysis, that remains a eternal problem to predict how the share market will go on. So a lot of applications are there as well. Now, this is a simple classification problem. The picture is given, and through some questions, we can find out whether it's an indoor picture or an outdoor picture. And we come to what is known as decision tree. So the picture is given as an input, and suppose the question is the top part blue, which looks like it's blue? Yes. So if it is yes, it comes here. If it is no, it comes here. Now if it is true, then is the bottom part also blue? So that means whether we are on the water or the sea or something like that. To find out that here the bottom part is not blue, so that is not true, so it's false. So it comes here, and finally the conclusion comes out that it's a outdoor picture. So decision tree that way is defined by in the form of a tree. That's what is shown on the right hand side. And rules from the internal nodes of the tree are called the root nodes. Each rule tests the value of some feature, like we have seen here. Each rule, based on the rule, the path is divided. So each rule tests the value of some features. Level training data is used to construct the decision tree. So we need some level training data where we know what corresponding to the input, what is the output. So that is known as level training. So because we know the output also, we can make the decision tree based on that information. And obviously the tree need not always be binary tree as we have shown here. More than several branches could be there. The popular tree type models are CART, that is classification and regression tree, which was first used by Bremen in 1984. Then we have Random Forest, again by Bremen in 2001. Then BERT by Chipman in 2010. So these are various popular tree type models. CART, that is classification and regression tree, is a greedy divide and conquer algorithm. Trees are constructed in a top-down recursive manner based on selected attributes. The attributes are selected on the basis of an impurity function that needs to be developed. Then the built-in feature selection mechanism, comprehensive, easy to design, easy to implement, good for structural work. That's the advantage of classification and regression tree. And obviously there are some problems also, but it may become large for complex problems. Too many rules lose the interpretability, which is very important for solving the problem. It has a risk of overfitting and sticking to local minimum. So those are the drawbacks of classification regression tree. On the right hand side, there's an example here, very simple example how the tree develops. This is just the history of the development of neural networks, right from 1940s. Then people used to talk about electronic brain. Then came the perceptron in 1957, and then Adeline in 1960. Then 1960 to 1970 is considered to be the golden age for computer scientists. In 1969, the XOR problem, name XOR method was used. Then after that, for quite some time, till 1986, not much of a development progress in this field. Then, 1986, came the multi-layered perceptor of that information. That opened up various methods. In 1995, we have support vector machine, which is very useful nowadays in solving many problems. Then in 2006 came deep neural network. Now we are obviously, as Professor PROF.C.R.RAO already indicated, that artificial intelligence is maybe in the future, for at least for the near future, that is going to be the technique that we have to use in solving the problems. So the first perceptor was developed.
Sorry to interrupt you.
So I'll skip some of these things. I'll come to the interesting problem that became the motivation for working in this field. So let me come to that problem straight away. We call it as a Dean's dilemma problem. It's a business case study. In fact, Professor PROF.C.R.RAO talked about business school and MBA programs. And there are various different types of MBA programs. Not that all MBA programs are really good. I have some interesting experience, but anyway, let me not go into that. So, Dean's dilemma problem is that we have seen in India at one time point, there are lots of business schools that were coming up. In fact, since my early days in Chennai itself, mid of 80s, I've seen a lot of business schools had come up. Some of them were really schools in the sense that in the morning the school will be there, normal school will be there, and in the evening it becomes a business school. So MBA classes will be held in the evening. So, and that time we have seen that even people graduating from IITs will go for MBA and then come to the industry. So that was the trend, and hence lots of MBA schools had grown up at that time. Many of them had to be closed because they were taking huge amount of money without investment guarantee. So the problem with the dean of a business school is that this program will not run unless the investment guarantee is there, or at least a good amount of placement is ensured. So that was the problem. There was data for 5 years, which we started working initially as a project at that time. And then we got into the problem, and then the thesis is completed based on similar kinds of problems. So these are the two papers. In fact, the very first paper was in offsets. We are talking about operations research. So the very first paper, it was an application paper, was published in offsets in 2018. And there, the problem turns out to be very interesting, and it's similar to the problem that I had been given in 1998. So I'll come to the problem. So placement of MBA student is a serious concern for any private business schools. The data collected is from a private business schools, and data is something like this. So we have the gender, male, female, and the various parameters like SSC percentage, HSC percentage, and then SSC board, HSC board, which stream, whether commerce or science, then degree percentage, then entrance test percentile, etc. So lots of features of that. In fact, the data contains 24 explanatory variables, out of which 7 are categorical variables, the other things are different type of data. And the response variable was only one, which indicates whether the concerned student was placed or not. So either it's yes or no. So that's the kind of data. Very simple data. Everybody can understand. This is the basic data that normally we get when a student gets admitted in any college. Now, based on this data, the problem that was referred to was that that particular MBA school, they were having about 60% placement. So they said that we have 5 years data like this, we can give, and whether you can suggest that what particular set of parameters that would be important for us to take students at the admission stage itself, so that the higher percentage of health is guaranteed. That's the basic problem. So this is similar to the problem of that was supposed to be in 1998, that given the population of the second city, population parameters of the second city, we have to pick up which particular set of people are going to the possible bias of that product. So it's a similar kind of problem. So here, we could understand that statistics alone will not be able to solve the real life problem like this. So we have to use a combination of statistical and machine learning techniques. And the goal was we would like to come up with a model that can help the authority and business to predict whether a student will be placed or not based on certain characteristics of that student at the time of admission itself to the profession. So that's the main aim. So these are the steps that we have used. So business school data set was the input. Then we have used the classification and regression tree. So this is the CT algorithm, classification tree algorithm, which gives us the different rules, the important features from the data. So the recommended features comes out from this tree, and also the prediction result from CT out, that is classification tree out. Now both of these, probably for the first time, we have used as inputs to the neural network. So this part is statistical in nature, this part is machine learning in nature. So we have used neural networks here using the outputs of the classification tree algorithm. And then finally we got the classification results. So I'll show you the these are the various steps in between. I'll show you the what we have got finally. And the theoretical part of this is published in Statistics of Current. There's a second paper from this particular project. So this is the tree diagram, and the output from this, that is this is the path that gives us the maximum placement as far as decision tree is the tree diagram is concerned. So these things, along with the prediction from the city that we have used here as the input for the neural network, and we have used only one hidden layer here, but the number of neurons we have done in the second paper, what should be the maximum number of neurons here, that should be sufficient. So, and then finally the placement status is obtained. So there are various other techniques that are normally used in similar kinds of problems. And we have just compared here the various quantitative measures of performance along with the different classifiers, and it was shown that the ensemble model or the hybrid model of classification technique and ANN, that gives much better, performs much better, and it gives about 92% accuracy as far as the placement is concerned. So, so solution is now from 60%, the placement percentage can be increased to 92%, provided the selected features are considered during the admission. So that's the basic thing. And then to show that this technique is not only, of course, we have done the theoretical consistency also, but then to show that it's applicable even for other data sets, we have used various other data sets from the Kaggle database and showed that how the technique works. So this is how I think there are some references given here. So I must thank the organizers again for giving us an opportunity to share this new area of development. I would say this hybrid method are not very old, so there are many scope of further research that we have put across in the papers. Thank you.
Thank you so much, Professor Chakraborty, and thank you for reminding me the time spent in Kashmir, really the beautiful time. And since we are celebrating the centenary birth celebrations of Professor C.R.RAO, I have one more incident. In fact, Professor Reddy and myself, we wanted to invite him to Srinagar for ISPS 2008 conference, but somehow we could not do it because he was away from India and he had some problem. But even if he was willing to visit the valley, he was willing like anything. And regarding his practical experience, which Professor Chakraborty shared, I don't know how many of us will dare to keep away our eyes from away. And this is related to the same incident. Professor C.R.RAO put a condition in the University of Jammu when they invited him in another ISPS conference. And he simply told them he would not be coming to Jammu unless his wife was to be invited along with him. So this is another aspect. He never wanted to keep her away. Really a lesson for us. So thank you, Professor Chakraborty, for sharing many things regarding the statistics, data mining, machine learning. We have really learned a lot from your lecture. I have another friend here, Professor C.K. Jaggi. We also met in Philippines in one of the Operation Research Society of International Nature. We met for the first time, and since then we have been friends. And really, he obliged many times, like Professor Chakraborty. He also visited University of Kashmir even during the trouble. Like Professor Reddy helped me many times in Kashmir in hosting international events. And really, it gives me pleasure to introduce Professor C.K. Jaggi, our another speaker. Professor Jaggi is from Department of Operational Research, University of Delhi. And he is the recipient of MIT Academic Excellence Award in February 2019 by MIT University, Noida, and Lifetime Achievement Award by International Organization of Scientific Research and Development, Visakhapatnam, July 2018. He was honored with International Best Researcher Award 2017 by the International Science Community Association in the 7th International Science Congress at Bhutan. Certificate of Excellence Bharat Vikas Award was awarded for loyalty, diligence and outstanding performance in the field of operational research by the Institute of Self-Reliance, Bhubaneswar in 2017. He has many things to his credit because of the time constant we are facing. He has many things to his credit. He was invited to deliver Professor J.N. Kapoor Memorial Lecture at the 20th Annual Conference of the Snana Parishad of India at Manipur University, Jaipur, 2017. He is fellow member of Operational Research Society of India since 2017. He is fellow member of International Science Community Association since 2012. He is an associate editor of Search and IJSA Springer and editorial board of the IJSS, Operations and Logistics, IJSOI, AJOR, IJECBS, JASR, and AJBS. His research interest lies in the field of supply chain and inventory management. He has enriched research experience with around 150 publications in journals of high repute. He has supervised 17 PhD and 26 MPhil. His papers have Google Scholar citation as 2275 use number, with H index as 24 and I-10 index as 40. Professor Jaggi is one of the thorough gentlemen I have ever seen. He is very nice in his behavior also, besides academics. I would like to request Professor Jaggi to please speak on this topic.
Thank you, Professor Akil, for me. I thank Professor Reddy also, and because I committed to him that I will be joining this webinar, but I forgot my roots in getting married during this period, and I'm not in Delhi. So I just said I will definitely be joining you, and that's why I am here. And I am not working in like Professor Rao said and Professor Ashish Chaturvedi talking about the artificial intelligence and neural network and so on. But I am working only as Professor Ashish said in the inventory management. That's what I am trying to do, and I'm just trying to just see that what best I can do and how I am using this strategy in my inventory with stochastic inventory modeling. I hope my screen is visible to you.
Yes, we can see it.
Thank you, sir.
Please go ahead.
I'm just trying to talk about, discuss few models which we have developed with the help of my students during our period of time. But what we are trying to do is we are analyzing the impact of G time on stochastic inventory systems. That's what we try to look at, how we go about that. Basically, what we see, anyone who considers that mathematic method of producing random desert is of course in a state of sin. It was statement made by the government human, and it was quoted here. That is where quoted from here. Now, here what we say, we talk about the stochastic inventory model, controllable lead time. Under various situations, for example, the controller could set up cost, backorder discount, uncertain supply, mutual coordination between vendor and buyer, and service level constraint. We will talk about all these things into this inventory, how we are. Because normally in practical situation, therefore, we assume that it is deterministic, invisible impact, which are practically not feasible things. But mathematically we do that. Now here we also talk about the utilization of JIT methodology or philosophy. JIT is a philosophy which itself would say that it's a low stock. JIT philosophy says it's low stock, shortening of lead time and the setup cost, high quality, improved service, etc. The main purpose is the best possible use of available resources and to reduce the process time as far as possible. Now, companies like Toyota, Ford, Dell, they all are currently utilizing this JIT philosophy and are trying to reduce the crashing of lead time. Now, inventory model can be categorized as a deterministic. Deterministic we all know because the things is known with certainty. And when we talk about the stochastic model, demand or lead time or both may be known or may be unknown. This probability distribution. When the actual demand exceeds the expected demand, or when the actual lead time exceeds the expected lead time, then one has to maintain safety stock. Now, what the safety stock which does is as a cushion against your uncertainty in demand and supply. Now, that's what we are talking about the safety stock. When we talk about the safety stock, now the safety stock we say it is directly proportional to the level of service being offered. Now here, the higher the level of service, higher is the safety stock. That is obvious that we're keeping extra stock, so we are going to have it heavy. And then we talk about the service level. Now, service level indicates that the ability of the firm to meet the customer's demand from the stock. It may be specified as a percentage of demand filled on time, or that is within a specific time period after receipt of the customer's order. Now, in case of organization runs out of stock for an item which is in demand and it leads to loss of business, and that has an associated cost for your shortage cost or the back order cost or stock out cost, all about that. And these costs are quite heavy in the sense of from the business point of view. Now, because the shortage cost includes the loss of potential profit and the sale of the demand period, loss of permanent customers, and here the major goal or consequences of out is the goodwill loss. Now, goodwill loss is basically provides a bad word of mouth or good word of mouth. Now, in case of stockouts, whatever are there, and goes a bad word of mouth, and that has got a very bad implication on the business. Now, to minimize the stockout cost, safety stock is generally carried. In this context, we talk about the JIT, that is just in time philosophy. And this philosophy itself emphasizes on the successful execution of all the manufacturing activities required to produce the product that and it has a fast delivery for the end user. Sorry for that. Sorry, some problem with my laptop. No, I'm sorry. No, the JIT helps in continuous improvement in the manufacturing process and in elimination of the waste, which ultimately helps the company to provide better products and services excellence. The utilization of JIT improves low stock, shortening the lead time and setup cost, high quality, improved service, etc. The main purpose is the best possible use of available resources and reduce the process time as far as possible. Now, lead time plays an important role in stochastic inventory system. Basically, the time between the ordering and the replenishment of an item and actually receiving item into the stock refers to, that is, we call it as a lead time. Now, there are some pre-assumptions that most of the officers have cultures have, I think the lead time is concerned negligible, where it has been realized that lead time can be reduced by decomposing it into several components and to make the system more efficient. That means the moment we can break the lead time into different components, then we call it as the lead time is controllable. The lead time is controllable, what that means that can be reduced by crashing it component by an added extra cost. That means the concept of network, like there we use the crashing of the project network scheduling, there we use the crashing, the same concept as we applied here, the crashing, and then we try to reduce the lead time. The components of lead time could be, we can say the order preparation, your order transit, suppliers lead time, delivery lead time, and the setup time. That is, we have different components. The first model we look into that, a deterministic model, It is specified by a set of equations that describe exactly how the system will evolve through the time. Now, here we try to see that when the demand is uncertain, the safety stock is added as a hedge against the stock out. Now, focus must be on the demand distribution during the lead time. Now, here the picture shows that what is happening at time, because whenever there is a variability in the demand or in the lead time, then reorder point is there, and then below the reorder point, then we have something in the stock that we call it as a reorder level, and then we have the safety stock as it goes. And at times, we are not using the safety stock, at times we are using when the expected demand goes beyond. And here what it is, so that how we use the safety stock. That is basically hedge against the stock. Now, reorder point, which we define the expected demand during lead time plus the safety stock. And here we say A as a safety factor. Here we just try to find out the safety stock and the service level. Now, normally we say that service level is 90%. That means we are assuming that 90% is the probability that the demand will be met during the lead time, and 10% we are taking the chance of the stockouts. And I said stockouts at times are very serious in nature. And these are the four possible combinations we can say. When the constant, then nothing has to be done, that becomes a sort of a deterministic case. And in 2, 3, 4, we have either one is variable, either my demand is variable or my lead time is variable. Or in the last one, we can say both are variables. And how do we handle such cases? Now, this is a simple, the constant demand and constant lead time. That's basically safety factor. We write it as an expected demand during lead time. And the safety stock, there is no variability, no lead time, everything is constant, then it becomes simple expected demand during the lead time. There is no variability in it. When either one is variable, that means demand rate, the demand during is variable, where lead time is constant, then we have our ROP is defined as this. That is a reorder point. And when there is a lead time variability in the lead time, the demand is constant, then it is defined as ROP is defined as this. When both are variable, then it is being defined as ROP is this way. And this we just say to be some small example that how it works out to be, because it is a 90% level of service, we are assuming that the value of the Z standard normal variate is 1.28. And here we try to find out what is the safety stock and what is the ROP, that is reorder point, which we try to calculate. The first model we try to look into the periodic dimension model with controllable lead time and the setup cost with the back order. Now, in this model, we assume the effect of controlling lead time and setup cost in the periodic dimension model with back order price discount, where the back order discount has been considered as one of the decision variables here. And when we see when unsatisfied demand occurs when supplier offers a price discount to the customer for the stock out item and try to secure as many back orders as he can for his business. These are certain assumptions and implementations basically that average demand per year, then we have a fixed order cost for the inventory cycle, inventory holding cost per unit, target level, we have a beta which is reflecting the demand, with back order during the stock out period, and which is lying between 0 and 1. And beta naught is the upper bound of the back order ratio, and pi naught is your marginal profit per unit, and pi x is the back order price discount offered by the supplier. The x is basically a protection interval demand which has a GDL effect with mean as d to d plus t plus l, where l is nothing but your lead time and t is the cycle length or the review period, and the standard deviation is given as of the demand during lead time, that is sigma as under t plus l square, and that is equal to 0, and protection interval is t plus l. and that is A, we have a safety stock. Now the length of the lead time does not exceed in the inventory cycle, so that we assume that there is never more than one single order outstanding in the cycle. That we are assuming. And the target level, we expect the expected demand during the lead time or the protection interval and plus the safety stock. Now here we say the lead time, say L is consists of n mutually independent components. The ith component has minimum duration AI and the normal duration is BI and A the crashing cost CI per unit. Now we arrange all these activities, all these factors, all the parts of these components of this lead time into arranging into C1, C2, C3. So that Cn is the lowest. That means highest and C1 is the lowest. That's an increasing cost. C1 is the least and Cn is the highest. Such that the reduction in lead time should be the first component first because it has the minimum cost, unit inflation cost, and then component 2 and so on. So in nutshell, if we try to find out the lead time inflation cost per cycle is given as this, that we can use it further in our model. Now here we are considering periodic inventory model in which the production interval demand X follows the normal distribution with PDF, FX and mean D plus NL standard deviation is this. The expected shortages is given as this. Basically this is what is when the demand is exceeding the demand. When demand is exceeding your stock. That is where it comes from today. And the expected net inventory at the beginning, that is calculated like this. And the expected net inventory at the end, that means beginning stock and meeting the demand during this period and that way. And then we try to find out the expected holding cost per period and the expected stock out cost per period. Now, two of the important concepts used in this modeling are backorder discount and reduction in the setup cost. Now, backorder discounting, most of the inventory system considers that shortages are partially backlog and partially lost. As some of the customers whose needs are not crucial at that time can wait and their demand to be satisfied while others fulfill their demand from the other source. The cost of loss will include profit loss and unspecified loss of sales. Now during stockouts, certain factors like well-framed products, fashionable goods such as your certain brands, hi-fi equipment, cosmetic, etc. affect customers' acceptance for backup. Suppliers' price discount is one of the major factors that motivates the customer to go for the back order and help him to secure more back orders through negotiation. This also facilitates the supplier to cut down the present future profit loss. Now, back order discount. This is assumed as a fraction which is like 1 of the demand during the stockout period can be back ordered, so the remaining fraction 1 minus beta is lost. And the back order ratio beta is variable and is in proportion to the price discount phi x, which is being offered by the supplier, and we take beta as beta naught phi x and phi naught. The beta naught is again lying between B11 and phi x is lying between phi naught and phi x. Then we also try to look into the reduction in the setup cost. Various components such as workers' training, procedural changes, and specialized equipment facilitates to reduce the setup cost, and which not only eventually help the firm to reduce the total cost in the long run, but also improve the working of the facility. Reduction of the setup cost, again we try to look at, and we have say that there are a number of components which constitutes the setup cost, and we say there are n mutually independent components. The jth component has a normal cost at EI and the minimum cost DI and the threshing cost FI. When the nominal cost reduces to the minimum cost so that there is a discontinuous relationship between the cracking cost and the setup reduction. So we have a range FI such that FNF the same way we arrange these components also in the heating cost of the crushing cost, and that we do it for the sake of convenience because the minimum heat cost is we pay if we start crashing from the first F1 in that order. So that is the minimum cost, and also the setup crashing cost CK is given as this. This is what we try to. Now here we try to model this model. Our objective is to find optimal value of the review period, lead time, and the back order discount in order to minimize the total expected annual cost, which is given as the ordering cost, the setup crashing cost, stockout cost, holding cost, and lead time. And that is what we try to find out is our objective, known as the expected annual cost here. Now, we can have two cases can be there. That is case one. We can have the demand is known, the distribution of demand is known, and that we assume it as a normal distribution. And the second situation is where the distribution is not known. But we do know, we have the information of mean and variance of this unknown distribution that from the data, and we will play with mean and variance of this data. So in case one, when the expected shortages are given like this, the phi and phi are the PDF and CDF of the standard normal distribution. Therefore, when we substitute that and we try to find out, we get the expected annual cost the system, and we have the three variables that which we are using. Now, in case two, when we have distribution is not known, there we approach the minimum calculation and the expected cost, that means which are expected shortage is defined as this now, and the expected annual cost is this way. Now, this basically now we try to find out the necessary and sufficient condition for that. The necessary condition for optimality, there's the replenishment, cycle time, lead time, back order discount, and the total expected cost could be obtained for each component of lead time and the setup cost, and nature of the function this has been checked for concavity and the convexity for the sufficient condition based on the second derivative. Now I am just explaining this second model. I won't get into more details of this, but this model is the stochastic inventory model with the back order discount under uncertain supply. Now what is uncertain supply? We say there are many reasons for uncertain supply. That means stock out, shortage in raw material, unpredicted machine breakdown, strike, etc. And this affects the buyer decision related to the of order quantity and the lead time. That means what we trying to see here, I'm just giving you order quantity was Q, the order point is this. Now here we say a random variable represents the quantity received, and then we say we impute the expected value of Y and order discrete. That means you received Y, the probability function of Y, given that Q units are ordered, but we have got the Y, we got less. And the rest is there, and this we have the bias factor also in, and just skipping because the methodology in this the same, except it is assumed the received quantity again is a random variable. Which the effective received quantity is like this. That means some bias factor is coming out, and then we are just using the same, and I'm just skipping because of what I want to show for the current one, that was the last model. I'm just skipping, and then we have another here. We have a we have added as a service level constraint because we're not keeping it as a free. A service level constraint implies that stock out level per cycle is bounded, and that was the thing that also worked well here. and we are having a bounding on that, and that we did, and that was also we got a good results in that. And I'm just skipping the modeling of this part as well. So then we have looked into the vendor bias capacity integration, a vendor bias model with a specific objective. Now here, what the problem, since we have looked into that buyer objective may be of shortening of lead time to fulfill the customer demand and in order to maintain, whereas the vendor may be having a different objective to reducing the setup cost. Vendor aim is to reduce the setup cost. Buyer objective is shorten the lead time. Both are having a different objective, and then we're trying to look into an integrated model how this works well under this situation of this lead time and this. And this was the modeling of that. I'm just skipping it because vendor buyer cost is there, and these were the some results. Skipping that, just coming to the next model. That is what we have here. Now, after doing all this, then we try to look into how we can try to look into this into for decaying items. That means for deteriorating product, how this controllable lead time and backorder discount works with this. Now, the main objective of this model was to uncover the benefit associated with the reduction in lead time and often backorder discount for decaying products. As far as my knowledge, my understanding, this area has not been explored much in this concept of this applying to for decaying products. But as far as my knowledge, there we try to look into the two cases again discussed for protection level interval, demand is known and demand is unknown, and we try to look into your minimax free approach. These are same notations which we are trying to use as mentioned earlier. The omega is a class of PS effect the protection interval demand during this, and S is a fixed cost that is almost the same. Now the item decay with a constant rate per unit on hand, the quantity of the decay is considered to be consumed, and thus the decay is like source of consumption also. That is what we say here. And here the inventory level review period is key. Units of time is sufficient quantity is ordered once reaching the target level R. That is there. Now here we have the same way we define the expected demand using lead time and the expected decay during production interval for the safety stock. That is what we are trying to change, which we have brought in your target inventory level. So otherwise we had expected demand during the production interval plus the safety. Now we are saying that it should be the target level expected demand during the production interval plus the expected decay during the production interval plus the safety. That is a change we try to find out here. The mu is the average number of units that decay per unit time, and safety stock, that is A into your A was the production level, service level, and then you have a standard deviation of the production interval, and the safety stock is like that. And which is we are calling it as Q represent the allowable stock out probability during T plus L, which means the service level is defined during the production. And again, the lead time has the same component, and we are really increasing out of the crashing cost. And here we are doing a lot between the length of the lead time in the component is, and we can find out the lead time crashing cost. And backorder discount we just explained accordingly. This model here we are model is different from the previous model and has to. He also did. This factor we are taking from the scientific paper, and then we are introducing, as we have said earlier, the service level constraint. That is the service level constraint we have added here in this model. and then we try to formulate this model as explained, that how we are getting the initial inventory and then ending inventory, then we are finding out the average inventory and then decaying cost, which we are calculating the expected stock out cost during this, where this is defined as, and then we try to find out your to maximize your ordering cost, the stock out cost, holding cost, lead time shipping cost, and the decay cost index. And this is subject to, that is service level constraint, and ID, which we define it as this. And also we assume that the backorder ratio beta depends on the backorder discount. Discount for the decaying period, beta is this, and R is this, where A is your sales. Now equation 1, we are just rewriting it subject to this service level constraint. And again we consider the two cases. One is a normal distribution and another is an unknown distribution. With the normal distribution, we get the expected annual cost as this, again subject to the same way we try to put into. The lead time demand with unknown distribution, we are trying to play with your mean and variance of the data. We are using a minimax approach. Lead time demand during unknown distribution, and we get expected annual cost with this, and your lead time demand is not known. In the lead time demand, again we have this component lead time demand for unknown distribution. Then we have a solution procedure, that how do we find out this expected value, optimal value of this, and solution procedure which normally we use, as I explained in the first model, the same way we are just proceeded with it in this. And here we are proposing a creative procedure that means for a given allowable stock or probability to find the value of A by checking the standard normal and thus obtain the value of psi A. Now for given A, psi A and each Li, we utilize the numerical expression between psi and phi M from equation 13 and for each pair of this Ti, phi X and Li, LJ compute the corresponding expected cost where, and they satisfy the service level constraint of equation 11, that is to check this. And then we find the expected annual cost where service level constraint is satisfied, then the expected level is find the local optimum. That's a solution procedure, that this is the minimax now. Again we are following a iterative procedure, that way we try to calculate with the different steps how we go about and we try to reach at the solution, and then we use the numerical example, hypothetical data, and we try to see that whether how this model works. Now we are taking normal distribution, because that we are taking 3 and component 1, 3, and the normal duration is, and we have a minimum duration and the unit duration cost. And the lead time that we are computing is 6, 8, 6, 4, 3, and that is the lead time cost is 0, 5.6, 52.4, and 1. Now for this table for normal distribution for beta 0, beta 0, 0, we are trying to find out, and this and theta here we are taking a 0.52. That means we are assuming the classical lead time when the protection interval demand is known for iteration rate for 2%. That means 2%. And we are assuming the service level as 98%. That is normal. We try to find out for beta 0, beta 0.2, beta naught, beta naught, and for different values beta 1. That is what we are trying to find out how this model will be. Now we do it for the service level 99%, and accordingly same thing we have used here. we're trying to find out, and that is now we are going service level of 96%, now reducing, increasing, then reducing to 96%, and here is 80%. Now we are taking more risk on this now. 80% level of service approach, we are taking it. And here we summarize the service level and we just try to see what is happening here. 98%, 99%, 96%, 80%. This we trying to see that the moment we are taking increasing it, the 80%, that means the cost is going to go very high in that case because of the service, I mean stock also levels are more, risk more than the total. That is again now 5% deterioration rate, then we try to look into the same setup or 5% deterioration rate. That's now 8%. We are just trying to look into, now we go for minimax and we try to do this same way. We have proceeded and we try to find out. Again we see that in 98% the expected profit is well, and the moment we are 80%, cost goes high and your profit goes down drastically. Same way 5% we are doing it, and then you are going for 8%, and that is what we observe here. That what happens when we solve the cases for different values of beta 0.2, 0.5, 0.8 and 1, where beta 0 represents complete blockage. That means nothing is supported. Beta 1 complete back order. And when beta is line between 0 and 1, that is partially backlog and partially solved. We have also observed that the total expected cost increases as back order ratio increases. Because supplier can fetch large number of back orders by offering the price discount to the the review period T and the maximum inventory level for deteriorated item decreases with the reduction in B. The total annual cost increases as the cost of retailing items increases. That the reducing of lead time and the expected cost increases the where the back order ratio is very natural phenomena and realistic in inventory modeling, but in the literature of deteriorated items inventory model, there are very few efforts which the setup cost, it seems to be higher, but eventually it reduces the total expected cost of the running any inventory system. Such kind of models facilitate the trade growth and satisfy supplier, buyer, and the consumer requirements. And these are some of the references. Thank you for the patient hearing and giving me an opportunity to share my thoughts here.
Thank you, Professor Jaggi, for enlightening us on late time and discussing various models of queues. We are really thankful to you. And I'm also thankful to Professor Chakravarti. I think we have 1 or 2 minutes. If somebody has any questions, please, 1 or 2 short questions. If anybody has any question, please clarification. I think none. So thank you once again, both the speakers. And of course, thank you, Professor Reddy, for giving me the time. So it's over to Professor Reddy for further actions.
Thank you, Professor Akhil.
Yeah, my pleasure, sir.
Sir, your mic is off.
Mine?
Right. Thank you, Professor Akhil, for sharing the session. And also I am grateful to our good friend Professor Jaggi. I am very happy there are only two universities are running MSc operational research courses in India. One is at Delhi, so now I am very happy that Jaggi has represented. And another one is from our Andhra Pradesh, that is Kurnool, War and SQC. It is a Rayalaseema University, which already Professor Anandarajari morning he spoke about his center, about his activities and war and SQC. So I am extremely happy that the two departments representation were with us. So once again I am very happy. So now in the afternoon we have there are three important lectures. One is and is going to be chair Professor P.R. Vittal, and there will be a documentary of Professor C.R.RAO, which will be now presenting in the afternoon 2 to 2:30, and at 2:30 onwards we will have Krishnamurti lecture. Professor Krishnamurti Garu, he is from CSAT Cochin, and Professor G. Arvaregren from he is now emeritus professor, former emeritus professor in Tirunelveli MS University, and the other one which we are Purit Pankaj Gupta, because of Pankaj Gupta is having a little work and we have shifted to tomorrow. But anyhow, in his place, Professor Dr. P.R. Vittal is looking to give a lecture. So today there are three lectures in the afternoon and documentary film. Now we have tea break. Thank you to all. So
So,
thank you.
Professor Reddy, I would like to supplement one more information.
Yeah.
At Aligarh Muslim University, we have a PG course which we offer, and PhD as well as other courses. We have a department of statistics and operational research. So it's a almost full-fledged programs we are offering in operational research.
Where in Aligarh?
Yeah, in Aligarh Muslim University.
I know that the Department of Statistics and War, but
Yeah.
I came to know that there is only one specialization paper in operation research.
No,
Similarly,
sir.
Kurukshetra
We have several.
University, yeah, Kurukshetra University is also Department of Statistics and War, but only
Yeah.
they are teaching only one is specialization paper war. But if you are teaching MSc
That's
Sir,
true.
not,
That's
Statistics War course,
ready.
I feel
But Aligarh Muslim University, they are offering exclusive degree.
yeah, we are offering exclusive degree
After
now.
that, they have got a different stream now.
Okay, sir.
Thank you.
yeah, thank you, Monisha. Please mute your that one mic. So it is an unmute. Now I request you to Monisha Bhattakur. Maybe she left. No?
Yeah, hello, Professor Reddy.
Yeah, thank you. How are you? So, okay, good
So
to see
I'm
you.
really thrilled.
Yeah,
It was so very good to hear all the great academicians of our country and abroad also. It was a great learning for me. I'm outside. I'm from corporate industry, but thank you for inviting me. It was really very very enlightening for me. Tomorrow I'll try to deliver a talk in the afternoon,
yeah.
and today, but I'm hearing from the beginning. It's very very good experience, learning experience for me. Thank you.
Yeah, 1 minute. I am happy to introduce Monisha. So when I went to Melbourne in 1997 for attending APOS, Asia Pacific War Societies conference. So there are only four represented from India. Apart from that, Monisha Vartakur also she represented. She had just completed MSc Statistics, and doing PhD she came to Australia, Melbourne for that conference. So and another two persons, Sharagopan and Ashito Kumar Mittal. So we four were there in the conference. After coming over, I think maybe that is a turning point for my entire academic activity. Because after coming over to India, I initiated Operation Research Society of India Tirupati chapter. Then from that chapter, so that the concept of time reduction, all the people, so that people have recognized that it is called reduction of the like that. So there is a strong force so that my academic work started after coming over from Melbourne. So that's why I'm very happy. After long years, 97 to still, so we never met Monisha only after I retired. So I gave some mails that recommending my friend for what former president of War Society of India and ISCS. So now I requested this time Monisha to speak something because she went to Stanford University for doing her master's program. Something I have seen her biodata, so it is excited that she gone through many ILRs. So now I am very happy to see you, Monisha, in this time. So tomorrow I hope that tomorrow
Yes,
afternoon.
yes. Sure. Thank you so much. Actually, when I heard about learning, de-learning, I work with Infosys, and there, basic everywhere, it talks about why statistics is so important. All the technocrats, they learn statistics and OR to actually work in the analytics programs. We'll, kind of implementing large scale IT transformation program in India, like GST network is developed by us, entire income tax departments, IT returns application, customs. So everywhere, we actually, the starting point is the OR and statistics, from where we move on to AI and all the big data. Now we are at the concept of live enterprise, which I will talk tomorrow briefly. So and then Narayan Murthy also, he keeps on saying that learning and de-learning is a something which if you want to grow, you have to do not only the system, not only for machine learning that you have to do, not only the system that has to learn and unlearn, but also the people who is contributing, who is coming up with, you have to continuously learn. So that is the what to say, the message we keep on getting from our management, and we try to do that. So that is why maybe in the last few hours, I really learned some of the things which is so meaningful for us in working for our programs. Thank you so much, sir. I come from Delhi University, so maybe Professor Jaggi, that I passed out long time back, 1993. So that is what. Thank you. I will.
Thank you, Monisha. Thank you. Okay. So thank you for your morning session is completed. So now afternoon session is a break. Whether you will join your way by 2 o'clock. So okay.
Thank you. Thank you, sir.
Thank you, sir.
Thank you.